Good morning, ladies and gentlemen. Welcome to the second day of the 9th CSI InApp National Student Project Awards final round evaluation. I request everyone to mute your audio as we are starting the process. It's the second day of our final round. We have our 7 teams ready with their presentations. Before we start it off, let us recap. We started off this year's process with more than 570 projects and went through a rigorous 6-month process and shortlisted the top 15 projects. The final round evaluation is divided into 2 days. Each project team has 30 minutes allotted to them, specifically 10 minutes for the presentation and 20 minutes for the demo and question and answer session handled by the judges. After this, the judges would discuss privately and score them as per the criteria. We had evaluated 8 teams yesterday. Today, let us continue with the remaining teams. The project will be evaluated by an eminent panel of 4 judges who are pioneers in their domain. The judging panel include, first, Mr. Satish Babu. Satish Babu is the co-founder and president of InApp. He is currently the chair of the APALO, Asian, Australian and Pacific Island Regional at-large organization of the Internet Corporation for Assigned Names and Numbers, ICANN. Satish has been an IT consultant, designer, developer and trainer for more than 30 years. He is the founding director of IC4, an academic as well as research institution of the Government of Kerala. Satish was the president of the Computer Society of India for the year 2012-2013 and is its Golden Jubilee Fellow for the year 2014. He was the IEEE Kerala Section Chair from the year 2011 to 2012. I extend a very warm welcome to you to start into the finals. Next, we have in our panel Mr. Brijesh Madhavan. Brijesh is the CEO of Curvelogics Advanced Technology Solutions Private Limited and a co-founder of Neobiosis Computational Genomics Labs. His focus is to grow Curvelogics into a successful artificial intelligence company through cutting-edge R&D and developing AI product lines centered around robotics, IoT, blockchain, genomics, big data, and advanced analytics. He has over 20 years of experience in advanced statistical modeling and machine learning and has held senior leadership roles heading advanced analytics, big data, and artificial intelligence teams in MNCs such as HP, IHS Incorporated, and EY. I welcome you, sir, to the finals. The third, we have Mr. Neelakandanji. Neelakandanji is a pioneer in the information technology industry with 35 years of experience as a developer, analyst, trainer, and delivery head. He was the past chairman of the Computer Society of India Trivandrum chapter and has been an active member of the CSI Trivandrum chapter for the past 28 years and has served the society in various capacities of office bearer and a managing committee member. He was an invited trainer to various Asian countries on topics such as software engineering, project management, data warehousing, agile methodologies, e-governance, object-oriented analysis and design, etc. He has held positions at many organizations of national importance like Regional Cancer Center, Thiruvananthapuram. I extend a very warm welcome to you two, sir, to the finals.
Thank you.
Next, we have Dr. Vishnu Kumar S. Dr. Vishnu Kumar S. is the head of Department of Computer Engineering at Government Polytechnic College, Nedumkandam, Kerala. He is currently the Vice Chairman of the IEEE Computer Society Kerala chapter. He was also the Chairman of the Computer Society of India Trivandrum chapter from the year April 2017 to December 2018. He is an active member of the CSI Trivandrum chapter as well as IEEE Kerala section. He has served the society in various capacities of office bearer and also as an MZ member. I extend a very warm welcome to you two, sir, to the finals. Now, let us get started with the second half of the final round evaluation of the CSI InApp National Student Awards 2020. The first team is from a college that has been consistently supporting great project ideas. Let us welcome the first team from Model Institute of Engineering and Technology, Jammu and Kashmir, ready with their presentation on the project Self-Driving Vehicle. All the best, team. Go ahead.
Hello, am I audible?
Yeah.
A very hearty morning to all the jury members present here today. Let's start with the presentation. We are not able to share the screen because the host has disabled it. So please, if anybody can enable the screen sharing. Thank you so much. A very good morning to all the jury members present here today. My name is Joyjeet Kaur and I, along with my team member Mohammad Noshad Bhatt, are today here to present our project, that is self-driving vehicle, in front of you all. We are 8th semester computer science students from Model Institute of Engineering and Technology. Let's begin with our project.
A self-driving car, which is also known as autonomous vehicle, is a vehicle capable of sensing its environment without any human intervention. So it uses a variety of sensors to perceive its surroundings. So self-driving cars have moved a long way. There was a time when these were considered nothing more than science fiction, but now they have become a very real possibility. Now, self-driving cars use a variety of technologies like deep learning, AI, etc. They also use a lot of sensors for them to work in difficult conditions like lidars, radars, cameras, ultrasonic sensors, etc. Now, use of all these things makes the cost of self-driving cars very high. For example, a lidar alone can cost in lakhs. But if we use self-driving cars in restricted conditions, for example, in college campuses, universities, for example, where the traffic is less and routes are already known, so there isn't actually a need to use all these technologies, which can help in reducing the cost of self-driving cars for such scenarios.
As you can see, this is a typical self-driving car, and what you can see is the sensor fusion technology in play. We use camera, lidars, ultrasonic waves, wireless systems such as GPS and other technologies to make a car more efficient and to increase its performance. But in the use cases where we do not need all these technologies, then the self-driving cars are too much costly for the system.
Okay, so to overcome all the problems with the existing systems, we have proposed a solution, which is to use a cost-effective approach to make self-driving cars for simple use cases like campuses, factories, etc. Now, how we are doing this is by using only those technologies which can make a self-driving car drive in such situations. We are using only a camera as a sensor in the vehicle, which is mounted on the front of the vehicle. So the feed from the camera is used for the computer vision purpose after that. Now we have implemented some custom algorithms for the purpose of object detection, lane detection, pedestrian detection, etc. Also, some special marked indicators are used for source and destination tracking.
All the data that we get from all the algorithms and all the detection models that we are using is processed in a very special processor, that is NVIDIA's Jetson Nano. It's a compute module with 128 core GPU and 4 GB RAM, which makes our processing a lot faster. All the outcomes that we get from the custom algorithms, they are fed to the Jetson Nano, and then some control signals are generated that in turn control the throttle and the braking system. But what is the markable point of the project? It is that it is a prototype which costs only 13,000 rupees, and then we can convert any e-vehicle into self-driving vehicle. That is the factor of the project. Moving on to the architecture diagram, this way we can easily understand the whole idea about the project. First, the feed from the webcam will go to the Jetson Nano along with some user interface. And then, as we say, the control signals are generated, which are fed to the electronic speed controller and servo motor kits, which are the drivers and controllers of the system. Then there are some motors which are attached in the e-auto and then some to the systems. Then those control signals are fed to the motors, which in turn help the motors to run. Then those motors control the acceleration, steering, and the braking system of the vehicle, which are the three main vehicle control systems. This is about the architecture diagram.
Now, this particular diagram shows the data processing workflow of a project. So what happens is the camera takes in the feed. So this feed is then sent to the processor in the form of images, as video consists of a lot of frames. So the processor pre-processes this data and performs necessary steps like reducing the size of images so that the model can run fast on the data. Now, after that, feature extraction is done where the features in the image are identified, and then the image object detection is performed using YOLO model. So the processor then sends appropriate electronic signals based on coded algorithms to the drivers and controllers of the vehicle.
Talking about the software implementation of the project, for object detection, we are using YOLO V2, which is a deep learning neural network. YOLO has basically three versions, V1, V2, and V3, wherein V1 is not that high on its accuracy and accuracy percentages, and V3 was high on computation factor, so we used YOLO V2. On the data set that we have comprised the college campus data set, the accuracy percentage of our YOLO V2 was 82.5%, which was quite efficient in detecting all the objects which came into its way. The three operations that are performed by the model are object detection, safe lane detection, and pedestrian detection. Object detection is where it detects the objects which come in front of it. Safe lane detection is whether it detects it is running in the safe lane or not, whether there's a vehicle in front or not. And pedestrian detection is where it detects whether there's a pedestrian on the sides of the road or in the front, or it has to stop or not.
Okay, so now talking about the hardware part, the main component that we are using is NVIDIA Jetson Nano, which is an edge computing device. It's a low-cost device and is quite powerful. It has a GPU on board and has 128 CUDA core, which help in faster computation. Now, this project is divided into three main subsystems. That is the EBS, which stands for Electronic Braking System, and it is used to apply brakes whenever necessary. So the other one is ESCS, that is the Electronic Speed Control System. So this helps in controlling the acceleration and throttle of the vehicle. So the last one is steering subsystem, which is used to give direction to the vehicle. So the acceleration and braking are controlled by the motors, which in turn are controlled by the motor controllers and drivers. So these are then further connected to the NVIDIA Jetson Nano so that they can receive appropriate signals from it whenever required.
These are various tools and technologies we have used. For coding, we have used Python. The hardware is Jetson Nano, Adafruit servo driver, and the quantum light web camera. And the technology, as we have earlier explained, is YOLO V2.
So talking about the future scope, so our project is not just limited to these use cases only. So there are a lot of things that can be done to this project in the future. For example, this can be improved further by performing testing in crowded scenarios and training the neural networks accordingly for the improved efficiency and improved safety. So the technology can also be commercialized, and that will help in developing low-cost autonomous mobility solutions for large campuses, universities, factories, etc.
Now, moving on to the demonstration of the project, our project is basically divided into two parts, the software and the hardware. So first, my team will start with the software demonstration.
Okay, so I will walk you through the software demo first. So this is the first video that I'm going to show you. So this was taken into a college campus. It simply shows different objects identified with their probability scores. So it just sends the appropriate signals to the hardware of the vehicle, for example, to stop when pedestrian or a vehicle is detected. So let's see this video. Okay. So now this part of the video, we have tested it in our own locality due to this ongoing lockdown. So we made some modifications in the code and improved it further, but we couldn't test into the college campus. So let's see this video. Okay, so here we can see two messages on screen. That is, one is a vehicle detected, the other one is safe lane. So what we have done here is we used a camera to detect whether the lane is safe or not. So let's see it this way. If the bottom left corner is origin, for example, we have two axes, x and y axes. So we have set some thresholds on x axis as well as on y axis to indicate the safe area. For example, if the bounding box of the vehicle crosses that particular threshold on x-axis, so the lane will no longer be safe. Otherwise, it will be safe. Also, we have done the same for y-axis also. So y thresholds are used to detect if the vehicle is far away from our vehicle or it is closer to it. So if it crosses that y threshold, only then the detections and appropriate steps will be performed. Otherwise, the vehicle will continue. Okay, so let's see it further. Okay, so here we can see the pedestrian is detected. So similarly, when the pedestrian is detected, as it's closer to the vehicle, it shows possible collision. So had it been more towards the right side, for example, outside that threshold that we set on the x-axis, like the previous vehicle, so the vehicle would have just moved without stopping. It wouldn't have stopped at that moment. Okay, so that was pretty much about it. So let's see the further video.
Now talking about the hardware demonstration part, I'll walk you through some of the videos that we have created in the college campus, in which we have placed the Jetson Nano and all the technologies in the auto, and then it moves by itself from a source point, for example, A to B. This is the initial phase of the auto when we could control the start and stop of the auto using our Jetson Nano. In this part, you can see my teammate is sitting in behind the auto and it's moving by itself from position A to B. Initially, we fix some path like a starting point and a ending point, and then in that, in between the starting and the ending point, the some of one of us might sit behind the auto, and then it would drive us from one point to another point. In this picture, you can see clearly the red light that is blinking is where we have placed the Jetson Nano for the testing and testing purposes. So this is how we used to connect the Jetson Nano to our system and then control it using our laptop. And then the auto would move from the point we wanted it to move from. This is the auto, the e-auto that our mechanical department of our college has assembled, as you can see in the picture. This is how we are controlling it. This is one of the pictures showing how we are controlling it through our laptop. This is the Jetson Nano that we are using. We have connected it through all the wires and Ethernet cables. This is how we have placed all the systems in our e-auto. Thanks. That was all from our side.
So, see, can I ask you one thing? So, how much of this was something that you leveraged from what is available open source? I'm not talking about YOLO, right? But beyond that, when we're talking about autonomous cars and things like that, there's so much content out there, isn't it? So much around how to build a autonomous car, very sophisticated, as sophisticated as using many radars and lidars, etc., or as simple as what you have put together, right? How much of it was uh, you know, you could leverage from the public domain, right? And it's how big is the team? Two people.
2 people, yes, sir.
Two
And our
people.
guide, of course.
Yeah, so it's a small team, right? So you need to be using what best is available out there, right? So that is one portion. And then what is that novel you bought in? What is that you brought in uh, beyond setting up a autonomous vehicle like this? And so that is one question. And second thing is, what is your frame rate? What is the frame rate you had? Because you have three different algorithms, three different um, things taken care, right? So you have object detection, and then of that you need to detect if it is a person, pedestrian detection, and then you have lane detection, right? Uh, did you run all of this on Jetson? That's one question. And what was the constraint you faced? And the third one is, so you talked about Jetson, you also talked about the laptop, right? So my assumption is you did all of this computation that is to do with deep learning on the Jetson Nano, right? And then there was still a requirement of laptop. It was that. So can you answer these three things? One is,
Yes, sir.
uh, so first, if I were to summarize, what is that you bought in Novel? What are the open source technologies that you used besides the deep learning model, right? Uh, and around the hardware, etc.
Okay, so yes, I'll answer your questions. Okay, so the first, as you asked, what technologies we have brought in, as in, like YOLO, it's already trained in object detection. So we used YOLO as already trained model. Plus, we trained it on our own system, like the campus data set. As I told you that we have trained it on our campus data set, but obviously the code and all for the YOLO model is already written. Apart from that, we have taken nothing from the internet. As you can see, we are using Jetson Nano and then connecting it to the controllers of the e-auto, so that is where you cannot like take something from the internet. Yeah, we have coded the Jetson Nano because Jetson Nano is a very new technology. People are using it, but still the codes are not found on the internet so easy about how to connect ESC to the Jetson Nano, how to connect the braking system. These type of codes are not available. So we just tried to figure it out as we were. Basically, we had done some work with the Raspberry Pi also in the past, so we were having some idea of how to connect these controllers with the e-auto and all. So that we have done. Apparently, we both have done the coding for the Jetson Nano on that part. Basically, our system is not using any lidars, so we are just using a camera. So camera feed is going into Jetson Nano, and then you need to code in the Jetson Nano itself of how when will for example the vehicle stop, when should the signal go to the Jetson Nano, and then when should the signal from the Jetson Nano go to the ESC controller. Basically, I'm taking an example of ESC only. So that coding we have written all on our part. What we have taken from the internet is the YOLO model, and that is the best YOLO model we could get for object detection. Then we trained it a little, and then we chose some classes and out of the YOLO, because we didn't need every class in the self-driving vehicle. We just need some pedestrian classes, some traffic signals, animals, and basically some lightweight vehicles. So we just modulated it in somehow so that we can choose only some classes out of it. So is what we have taken from the internet. Rest we have coded by ourselves. About your second question, no, there's no need of lab. Am I clear with the first question, sir?
Yeah, go ahead.
Okay. About the second question, about why we need a laptop. No, we don't need a laptop. We are just SSH. We are just using it as a screen. So my laptop is basically acting as a simple monitor, a screen that will be in like for example, when the vehicle is totally ready and we have constructed everything, then obviously there will be a screen in the auto where you need to like just touch where you have to go to department A or department B. Should we start the journey, should we end the journey? So some basic instructions will be written on that interface, right? So that interface we are just replacing for the time being for the testing with the laptop. So that is why we had placed the laptop there. Every coding part is done on the Jetson Nano because that is the part we are doing all the object detection and all that kind of stuff. So the laptop is just being used as a screen, you can say. So that through we are SSHing and giving it the commands, running the scripts. Then basically when the user interface will be ready, then on a click the script will be run and the operations can be performed. So what was your third question?
And what was your frame rate? Because you had three different things running, right? Like lane detection and pedestrian detection and maybe superset of that, which is detecting other objects, right? So, uh, how are you running this? Uh, you know, uh, was it the same YOLO's output that you're using for doing all of this? And um, can you comment more on that? And what your frame rates were, right? So how much frames could you process? Because this is something that is required in real time, right? And if so, what speed can your vehicle go at, right? Given the frame rate that you have, right? What speed your vehicle should be going? Have you thought of something like that?
Okay, sir. So the frame rate that we tested for Jetson Nano, it was around 8 to 9 frames per second. So which is quite good for some low speeds. Obviously, we can't run the vehicle at high speeds in the campuses. So for example, it can run on around 20 to 30 kilometers per hour, not more than that. So frame rate of 9, 10 frames per second is quite good for that purpose.
When you add the monitor, touch screen or so, what would your cost increase to now from 13,000? What would it increase to now?
So that will depend on the device of that cost, maybe 4 5,000 more for that purpose.
Okay, thank you.
So that is if we need to give the instructions to it. Otherwise, we can run the Jetson Nano as an edge device, like as the Raspberry Pi is used in robots, etc. And the screen is not used there, so we can do it that way also.
Yes,
Sure.
sir.
So, did you take into consideration other aspects of safety, when you should apply a brake, when you should not apply a brake, etc.? Right. There are times when maybe moving your vehicle in a different direction is a more safer thing, and not applying a brake, right? Have at this stage, I know it's a two-member team, too early to do anything like this. You might not have sufficient time, but have you thought through that, right? When you should be applying a brake? And then it gets to a more philosophical question, right? If there is a kid and a
Yes,
old
sir.
person, whom should you avoid, right?
Yes, sir, but that I think that philosophical question is a question for even the big companies who are making a self-driving car into play right now. The questions like if there's a kid or an old man or someone suddenly comes in front of it, these are all the main questions which are still the question for the companies who are also developing self-driving cars into play.
That
But
is true.
your question about have we thought of? Yes, it's a two-member team and we were working at a pace we could work, and I think we have completed the most of part of it. But yes, we have thought of it also, when should we apply the brakes and when should it stare around that person. In some cases it can be, so we were at the last phase of it, that is controlling the steering part, where we can just for example, there's someone in front of you and you can go which in that case the algorithm can be applied in which the side lane is free, because we, for example, we are going in this direction and the car is coming from that direction, and if there is nobody in that direction, you can steer your vehicle and go apart from applying the brakes. So that is the steering part of how many angles you need to rotate it, the steering. And that is we have implemented that model with we have connected a stepper motor to it, which gives signals in binary steps. So it just rotates your steering into steps, and then can go along the person, not to stop at that particular position. So we were in the last phase of it, but due to lockdown we couldn't complete that part, obviously. But yeah, we have thought about it, like the algorithm we are using in which we are detecting the safe lane. So when there's a safe lane inside of it, then at that time we can just steer our auto through with the side of that person, and then can go from the different lane and not stop if the person is ahead of us.
Sure. So I think I will park my rest of the questions after the rest of the judges have asked. Um,
Okay. Okay. It was a good work for the, especially when we consider that it's a two-member team. So
Thank you, sir.
I have a couple of questions. You
Okay.
mentioned that it is the accuracy you got is 82.5%.
Yes, sir.
So how it is compared to the required accuracy, or if anything like may not be there, may be a statutory thing in India at least. So otherwise, in industrial practice, what is the level of accuracy, or if you cannot compare it with a highway driving vehicle, I know, but there are certain autonomy restricted to a parking place. So in such cases, how do you compare your 82.5% accuracy?
So the accuracy, as I have written also in the slide, it's of the college campus dataset that we constituted. So basically, with our camera, we took like around 20 to 25 videos of the campus. Basically, we just hold it in our hands and then move around in the campus and made the videos. And then we tested like if there was a person in the middle of the road. So when how many percentage was there when it was detecting the person right, and sometimes
Okay.
it was missing the person also. For example, the person just walked through in from the middle of the road and there was no detection by our model. So similarly, we tested it on 25 like 20 to 25 videos, and then we came out with the results of like how many percentages accurately. Basically, we are detecting only three things in it. Actually, the object detection model YOLO has different percentage on the different data set we are using it. Basic, if it's Pascal Vogue, if it's Coco data set, but then they are using every class of 20 to 25 classes they are testing on it. But when what we are testing it on is the pedestrian, if it's detecting it right, the cars, the two wheelers, and then the signs if there are any. So in the four things we are detecting, we are testing our model on. So based on that, the result of 20 to 25 videos, we have just jotted it down. Like we have come to the conclusion that it gave us around 20 to 23 percentage on how when it detected the things right and when it didn't detected the things right. Comparing it to any other system, as you told me, like if you compare it to any other system, then that depends on different campus scenarios, because we have only tested it in our campus. Different campus have different, like they have different lanes, maybe some have four lanes also, different scenarios, different
Okay, so sorry to intervene.
okay,
My
sir.
question is that is what is the relevance of this figure to an industry standard? Is there anything like, if there is anything like that, an industry standard?
No, so we have not like measured it within the industrial standards as you are saying.
Okay,
Like
okay,
the
understood.
relevance, like we are just making it to industrial relevance. We have just jotted down to a conclusion of
Okay,
percentage.
understood.
Okay,
So,
sir. So this YOLO also we found it to be the best model there. This is the best
yeah,
open source
okay,
model. So the companies like Tesla, etc., that they might be using something better, but that is not open source.
okay. So my
Yes.
another question is that, say you demonstrated an auto rickshaw, okay, that was great. Uh, but my question is that to what extent your system is integrated to that? Because you mentioned initially that it is the control is applied to brake, throttle, and steering, right?
Yes, sir.
So in your demonstration, which part, or do you control all the parts, or you control only uh, a few of them, or no more of them?
So in the hardware demonstration that we showed you, are you
Yeah,
asking
yeah,
related to that? Yes,
yeah,
so that I'm telling you, the braking system and the acceleration system. Basically, are three parts we have in the architecture. We have designed the three parts:
yeah.
acceleration, braking, and steering. So
Okay,
the two we were able to show you. The steering part, as I told you, we were on working on it. We have implemented the code and everything is set, but we couldn't test it on the auto and took a video due to the lockdown. So
okay,
what we are
understood.
showing is steering. It's a steering part and the braking part.
Braking
Okay,
and acceleration, sir.
Oh,
okay,
sorry,
understood.
braking and acceleration.
Okay,
Sorry,
not steering. Okay, understood.
not steering.
Now,
Yes.
one more question. Did you, okay, anyway, probably you might not have reached that stage, but you had in mind about the kind of giving some roadmap so that within the campus it can drive autonomous. And if you have,
Yes, sir.
what was with you in your mind?
Yes, sir. That is lane detection part. Are you talking
Yeah,
about like,
yeah,
yes, sir.
yeah.
The roads usually have the white lines on the right and left of it. And basic models that are used for lane detection are like those two lines are taken into consideration. And
Mhm.
then some mathematical algorithms are applied to the lines to just find a point where the 2 points, two lines connect.
Okay,
So that is the basic algorithm that we have also implemented in the auto. But the our college was like on the way to make that markings on the road, but we have still implemented it in our project. That is a simple lane detection where the left and right white lines will be detected, marked red through some mathematical equations. The common point where the two lines are joined is detected, and then the camera just focuses on that point and moves in the safe line following that point. So
okay,
that is the lane detection we have
okay.
implemented.
Thank you. So, Vishnu, do you have any questions?
Okay, good job. And I'm also concerned, I do have a concern with the 82.5 percentage accuracy, because driverless vehicle uh, needs almost 100% accuracy, but you are using all V2. And also there are misdetection when you demonstrated uh, in the right side. It has been shown that train, truck, and a person is driving a scooter in front of the camera or in front of your vehicle. It has been shown that it's a person. See, if you are using acceleration system and braking system, if a scooter is coming from the opposite side and it has been detected as a single person, there is a speed variation. If you have to apply the brake at a proper time, you should have to evaluate the threshold value, and in an appropriate threshold value, the brake must be applied. So if it is detected as a person, definitely there will be accident. So misdetections are there. And I would like to know what are the different algorithms. You have mentioned algorithms. A particular algorithm is used. An algorithm is used for the line detection. And I would like to know what are the different algorithms used in your project.
Yes, so basically the first question of yours I would like to answer. In the demonstration, after the person, it's also detecting the vehicle wheeler also. It's saying vehicle detected, safe lane detection. It is trained to detect two vehicles also, but first it detects the person, and then the person, it is not that person on which the car will be collided. Then I think after 2 seconds, it's detecting the vehicle also. So it's detecting correctly the two wheelers on which the people are just sitting. And talking about the detections, yeah, that is the problem I think with every model that we have, that it misdetects at some point or the other. To overcome that problem, we have selected only some classes. Like for example, there is a car in front of it and it's misdetecting it. So we are not taking the like the heavy motor vehicles like train and trucks in our classes, so that it doesn't affect our system. For example, it's designed for the campuses, and in the campus only two wheelers and four wheelers are allowed. So we have just taken out the classes of two wheelers and four wheelers, so that the chances of misdetection are very rare in the system. And if it's detected, then it doesn't affect the braking and the acceleration system of the vehicle. So this is what we have done. Talking about the custom algorithms that we have designed, my teammate will walk you through about one custom algorithm that we have worked on.
Actually, that is the one I discussed in the software demonstration part. So what we are using is, for example, if we divide a frame into a grid, so there will be we can just take note of the distance, how if the vehicle is far away from the vehicle or not, whether it is in the safe area or not, based on some thresholds. If we set, for example, if there's a line in the middle, if a vehicle crosses at particular point this line, so it will no longer be a safe lane, otherwise it will be a safe lane. So this was one such algorithm that we used.
Yes, and the second of the lane detection, it is an open source algorithm. So we have not we have not written the code for it for the lane detection. We have just used it in our code. Plus, the our campus is not still having the white lines on some of the roads, so we are not using it as such. But then we have implemented it and put in the Jetson Nano as such. So we have taken it from the internet only, that algorithm of lane detection.
Okay, that's all from my side.
I had, I know we're
Okay.
running short of time. A couple of quick questions, right? So when we're talking about, applying brake, right? So there are a couple of problems with what you have, right? You have your camera, it doesn't have depth details, isn't it? It doesn't
Doesn't.
have depth details. You don't know which person is a person 5 meters away or is a person 30 centimeters away. You don't
Yes,
have
so
that details. Hmm?
that is the algorithm that my classmate is talking about. Along the x-axis and y-axis, we have
Got
given
it.
certain threshold values. Like basically, we are dividing the frame into certain parts. And then we, first of all, the basic problem is like we don't know when it's far or it's near. So we have just mounted the camera in that direction that it detects the nearest possible pedestrians and cars, because it has to do nothing with the objects that are very far away. You do not have to apply the brake when the person is 30 centimeter away, right? So we have mounted the camera in such a position that it just detects the people which are in the boundary of that car and a little far away also. Plus, using the algorithm that my teammate is explaining, we have kept some threshold values in X and Y. And if that person, if the pedestrian or any car in front of an our e-auto is crossing that threshold value, then only we are applying the brakes. And then threshold value is only in like it will pass the threshold value when it will be very near to the auto, that the auto can hit the pedestrian. So that is the
Yeah.
basic algorithm we have
So,
implemented.
so there are a couple of questions around that. See, one is when do you apply the brake, right? And your car, because of inertia, and the way you decelerate, right? Your vehicle stops not immediately; it stops little further, right?
So most of the times it stops immediately because we are not just stopping the motor, we are applying the brake. And most of the time, it all the tests that we have done, it stops. Like immediately doesn't mean even the cars, manual cars that we are driving don't stop like very immediately. If they
That's the
stop
point.
at the very point, then it can the skid over. So
That's
it
true.
takes 1 second, but then of the all the tests that we have done almost 20 to 25 tests on different videos. All the times
Rajesh,
it
I
just
think it's
stopped.
time we have to stop now. It's only 5 more minutes for the next presentation.
Okay, okay. I think we should stop now.
Okay.
Anyway, good work. You
Thank you,
people
sir.
continue this good work and best of luck.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you
sir.
so much.
Thank you.
Thank you.
Thank you, team. Now you may leave.
Okay. Thank you.
Judges, you can move to the discussion room. And the next presentation will start at 9:45. Um, Hi, Arpita. Let me give you a slight introduction before you start. You out of the 30-minute allotted time, you have 10 minutes for the presentation, 10 minutes for demo, and the remaining 10 minutes is for the question and answer session.
Okay, ma'am. Okay.
Okay. Next, it's my pleasure to invite once again the second team from the same college, Model Institute of Engineering and Technology, Jammu and Kashmir, to present their project on the topic Evaluation of Teaching Effectiveness by Video Streams from Camera. All the best, dear. Go ahead.
Thank you. Hello. Hello.
Hello.
Please carry on.
Go ahead.
Am I audible, sir?
Yes, yes.
So is my screen visible to you?
Yes, yes, yes.
Okay. So good morning, everyone. My name is Arpita Gupta, and I am a final year student of Computer Science Engineering from Model Institute of Engineering and Technology, Jammu. My project is titled as Evaluation of Teaching Effectiveness by Video Streams from Camera. In this project, we are trying to analyze the overall attention of students present in a classroom and then generate an attentiveness index for the classroom. So let's proceed. So the problem which we identified was that improving classroom teaching effectiveness is of great importance for educational institutions. Student attentiveness is a key element in determining teaching effectiveness. For example, if a student is more attentive in a classroom, he or she may be able to grasp the content in a more fruitful manner. That's why analyzing the attentiveness of students present in a classroom and quantifying the attentiveness is of great importance. So we thought that we should solve this problem. Even and if the student attentiveness is quantified, then even we can get help to devise methodologies and strategies to improve teaching effectiveness so that the learning outcome for the student is achieved. This is the problem which we identified, and we decided that we should solve this problem. Solution. So the solution which we have proposed is a artificial intelligence based solution which is based on real-time video stream analysis. So what our solution does is that it takes an input video stream of the classroom scenario made with the help of an IP camera. It processes that video stream, and then it analyzes the attention of the students present in that particular classroom video stream, and it generates an attentiveness index. We have done it with the help of a novel and custom algorithm which we have devised that we call as AEA, Attention Evaluation Algorithm. So this is the comparative analysis of our project with respect to the previous existing systems. There are some of the systems existing that's called predicting students' attention in classroom using Kinect facial and body features, and some of the other systems like deep gaze and other systems. But the approach the approach and limitations which we identified in those systems were that, for example, in gaze point estimation, they used to track the movement of eyeballs and the gaze of the students present in the classroom. So for that, we need a very high quality and high resolution camera that's called Kinect camera, and that would cost us around like 50 to 60,000 per unit. But the approach which we have used is face detection, and after that we have devised our algorithm. So face detection, we have tested it, and we have done it with a very normal resolution camera that's called an UniView IP camera with a resolution of around 2 to 3 megapixels, and that would cost us around just 3 to 4,000 per unit. So that's why we wanted to devise a solution which is both computationally efficient as well as cost efficient. That's why we did this approach. And apart from that, in existing systems there were individual analysis, like each student was identified, but in this system we are working on group analysis, and we are generating a collective attentiveness for the whole class. We are not targeting each individual or each student. So this is a comparative analysis with respect to the existing systems. Coming to the implementation part, we have used an IP camera that is installed in the classroom facing the students. Then we have done face detection with the help of a neural network that is called multitask cascaded convolutional neural network. So that does the face detection pretty much accurately for us. After that, we have implemented and devised an algorithm that is called as attention evaluation algorithm to track head pose movement and generate attentiveness index. This system is fully tested, developed, and implemented at MIT Jammu. So coming to the functional workflow, this is the functional workflow of my project. Firstly, the video stream comes from the camera with the help of the camera, which is placed in the classroom. And after that, video stream is processed and the face detection of the students is done. When the face detection is done with the help of the neural network, after that comes in work our algorithm which we have used, that is AEA. It analyzes the attention and calculates the attentiveness index. After that, we have kept a threshold for the attentiveness index as well. If the attentiveness index falls below a particular threshold, we can just send a text to the teacher that like the attentiveness in your particular classroom has kind of decreased. And apart from this, we have developed a dashboard as well. This dashboard can be used to view analytics of attention. For example, what was the level of attention in this particular class on that particular day. So these kind of metrics and analytics can also be viewed with the help of a dashboard which we have developed. So coming to the technology stack, and the technologies which we have used in our project are computer vision, deep learning, and artificial intelligence. Hardware used includes UniView IP camera for input video feed. Machine details are Dell Precision Workstation processor and Intel Xenon processor, which we have installed in our CRI lab at our college. And for GPU, we have used NVIDIA Quadro RTX 4000 processor, which gives quite good results. So that is also installed in the CRI lab at our college. And the platform used includes CentOS 7 and Python 3.6 as the programming language. The framework used includes TensorFlow 1.14, NumPy, and Pandas. So this is the overall technology stack which I have inculcated in my project. Hello. Hello.
Go ahead.
Okay, sir. So this is one of the demo snapshots of my project. Here you can see that it is a classroom scenario, and the students which are kind of attentive are being circled as green, and the students which are a bit distracted are being circled as red. So this is the way which we have tried to visualize the scenario. And for example, if you see that girl at the back, she is circled as red because she is a bit not attentive right now. So in this way we have visualized it. This is another snapshot from my demo where all the students were attentive. So almost all the students are being circled as green. So coming to the demo video, I have a demo video for my project. Let's proceed to that. So as you can see, the students are sitting and the camera is being recording recording their feed. And so the students which are then looking around or a bit not attentive, that guy is now circled as red. So those are being circled red, and those people who are attentive are being circled green. And apart from that, if you see on the top right corner, we have plotted a dynamically changing bar graph which tells us the level of attention and not attention in the classroom. Green signifies the level of attention in the classroom, and the red signifies the level of inattentiveness in the classroom. So in this way, we have done this. So coming to the dashboard, this is this is a snapshot of the dashboard of my project. As you can see in the sidebar, there are four major metrics. These metrics are daily analytics, monthly analytics, peak hours, and teaching effectiveness. So the daily analytics signify for example, we want to check on Monday what was the attentiveness index on this particular classroom. So this would give us the daily analytics. Monthly analytics would give us the analytics of attention in a particular classroom on monthly level, on monthly basis. And peak hours would signify, for example, what are the peak hours of attention in our institute, what are the peak hours of attention in our class. So we can calculate that with the help of the analytics obtained. And one more thing is teaching effectiveness. So what we can do here is we can go just select a particular teacher, and according to that particular teacher we can see what is the teaching effectiveness of this particular teacher. So this is another snapshot from my dashboard. As you can see, this is the attention level of a class called CSE A1. So this is giving the daily analytics. On Monday, this was the attention level. Tuesday, this was the attention level. So this we have done with the help of the bar graph. Next is the department-wise analytics. So this, for example, we can see that CSC department, this is the level of attentiveness index for different days of the week. So this we have done with the help of pie chart. So I also have a demo video of the dashboard. I'd like to play that. So as you can see, these are the sidebars which I showed you in the snapshot as well. So if we click on daily analytics, then if we can get two options, choose class and choose department. Similar goes with monthly analytics, choose class and choose department. By means of class or department, we can see the analytics. And for teaching effectiveness, we can get the option of choose teacher. And when we click a teacher, we can see the teaching effectiveness. So if we click on daily analytics, choose class, and if we click on a particular class, then we can see the attention analytics for that particular class with respect to the daily weekdays. And if we click on a particular department, we click on CSE. So this is the kind of data which we get for the CSE department on daily analytics. Apart from that, this is the monthly analytics, and these are peak hours. For example, you can see like from 10 a.m. to 11 a.m. this was the attention index. So these are the kind of metrics which we are trying to derive from the data. And the teaching effectiveness is like we choose teacher, we click on a teacher, and then would get the attentiveness index for that particular teacher, the teaching effectiveness in a particular classroom. So this was all about my dashboard. This is a demo of my dashboard. So coming to the future scope. The future scope includes like we were also working on the same, but then this lockdown thing happened and we were not able to work on it on these kind of things, but still we are working from home and trying to implement these as well. So the future scope includes to handle large number of video feeds coming from different classrooms in a computationally efficient manner. Since this project has to be deployed for different classrooms, currently we have done it for 2 to 3 classrooms, but then eventually our vision is to deploy it for multiple classrooms. So we have to handle all the video streams which are coming from a lot of classrooms in a very computational.
Did we lose her?
Yeah, I think he's having some problem with the connectivity. Arpita, are you there? Hello? Hello, Arpita, you're on mute.
Hello, and now am I visible?
Yeah, you're visible.
Okay, sorry, I think there was a network issue.
Okay, okay. Continue.
Just a second. Yes, yes, I am here. Wait a second. So is my screen visible?
Yes.
Okay, thank you, sir. Sorry for the interrupt. That was a network issue. So this includes a frame optimization, and the next future scope which we have is to increase the accuracy, that is from current to 85 to 87% to 95% through additional training and more gathering of data and testing it on more videos as much as possible. The next, since I'm doing this project under the guidance of Dr. Ankur Gupta, so we have this vision as well to file a patent and commercialize it as a product in future. So this is the future scope of my project. So thank you. This was all from my side. Thank you. Thank you so much.
Thank you. Maybe I'll take the first few questions. So, see, you said you didn't use, you tried to look at what is available in the market right now, and people were using Kinect, for example, right?
Yes, sir.
What is the major disadvantage of not using a device like Kinect? So, there is a major problem by not using a device like Kinect. What does Kinect bring? What is the advantage that Kinect bring? Have you thought of it?
So when I was in the research phase of the project, so I searched about the prior heart of the project as well. So I found this, that people are doing a Kinect facial camera. So what I think the advantages that Kinect brings is that it is of high resolution. It gives us the video feed in a very efficient and a very highly resolution video feed. So that is a kind of advantage the Kinect facial camera brings with us. But since it costs high as well, so we
Actually,
wanted a solution.
sorry to interrupt. It costs around 15 to 20K only. Actually, the whole Xbox device costs you less than 40,000, 30,000. So with the computer, with the sensor and all of it. So no, the point is, the cost is a factor. You said 3,000 is your device, and that
Yes,
is a
sir.
big difference. And but Kinect has depth in it, depth detail in it, which means that it can monitor 3D facial expressions and all of it. Right now, in your analysis, in your feed, I also saw there are mistakes where when a girl puts her hand somewhere close to the mouth, and then it starts showing wrong. Uh, it says they're not attentive, right?
Yes, sir.
Like that, what kind of issues did you face, right? How did you handle the false positives and the false negatives kind of scenario in your classification?
Yeah, okay, sir. So this the demo video which I showed you, it is after a lot of testing and testing it on a multiple videos. So when initially I started testing, there was not this much accuracy which like this which is there in this kind of video. So we tested on those videos, and then we eventually came up with solutions that this here we are going wrong. We need to fix this, and then we came up with this much of precision. The false positive which I if you're asking that how did I handle false positives, so false positives are there are some mistakes. For example, some person is classified as even wrongly, even if he is attentive at that time. But since from the start of my project we are focusing on group, we are not focusing on each individual or each person. Here we are focusing on the whole class. So even if for example there is this class of 30 students, and for example at worst case 4 to 5 students are like 3 to 4 students are classified wrongly, but that would not have like much effect on the attentiveness index of the whole class. So that's why and even if we are trying to improve the accuracy, but since our goal was group analysis and generating an attentiveness index for the whole class, so that's how I handle the false
Okay,
positives.
so maybe it's worth exploring this, right? So there is a trade-off between the false positive and the false
Yes,
negative,
sir. Yes,
right?
sir.
Now you need to figure out in your model what is that you're okay to take. Are you okay to take more of a false negative or more of a false positive? And depending on the business or depending on the problem you solve this, you need to figure out what kind of trade-off you need to do, right? It's worth exploring. That is my point.
Yes, sir.
Right. And your score that you mentioned, you talked about an attention score, right?
Yes, sir.
What is that score?
Attentiveness index.
Yeah, what is
Yeah.
the calculation that goes into it, and what is the advantage of it compared to? Did you devise that yourself, or is it an existing standard score that typically
Yeah,
is?
so we have initially we are using face detection. So we are using face detection with the help of a pre-trained network. So that network we have used that was available, that was MTCNN, multitask cascaded convolutional neural network. After that, whatever processing is done, that is done with the help of the algorithm which we have devised. So that is called AEA. So what that does is, for example, it analyzes the range of movement of the head or like the face of a particular person. It does face tracking, and on the basis of that range, it classifies each person as attentive or not attentive, the red and the green circles. And then eventually we calculate the percentage of students attentive in a class.
Yeah,
So that is done with the help of simple mathematics. Based on the number of students which are classified as attentive, we calculate the percentage, and that we have used for visualization.
so what is on your numerator? What is on your denominator in this case? You have a percentage calculation, some proportion, right? What
Yes,
is
sir.
on the numerator? What is on the denominator? If you had to summarize, I
uh,
understood
yeah,
you're
yeah.
talking about ranges and all of it, but
Yes, sir. So for a percentage of attention, the on numerator there would be the number of people who are classified as attentive, and in denominator there would be the total number of students.
okay. So you mean, and there is a threshold which you have set as the
Yes, sir. Yes,
range.
exactly.
Okay, thank you. And see, one more thing is when you're talking about pose, right? Pose is such an important thing. In your case, pose has not been taken care as much, and that's where I think Connect and all of it comes it plays a big role. Your focus is more on gaze, right?
No, my focus is not on gaze. My focus is on face. I am doing the face tracking, the range of movement of the face. If I have to focus on gaze, then I have to go for like a very high resolution camera that could give us the feed like that. But since I'm not using a high resolution camera, so that's why my focus is
Detecting
on the face.
face. And yeah, so okay, which means that a side pose versus a front pose versus tilting, or you're tracking. So you're not even looking at what side they're looking at, or you're just tracking how much movement is there of the head. Is that
Yeah, the range of movement. We have like analyzed that for different tested videos. So then we came out with these ranges, that this much range is okay and all that. And then we classified each person as attentive or not attentive.
okay? Some people are generally very active, right, and they can't sit tight. So is that a problem when it comes to your algorithm? Okay, these are
No,
questions
no.
that you need to think through. I think because people's personalities are different. People can move, people can remain still, right? Someone can be attentive and not moving at all, right?
No, sir, there's a kind of backup for that as well.
Mhm.
Like this question you asked relates to a scenario. For example, if a teacher is moving in a classroom, there are some teachers who move a bit while teaching. So obviously the students would look here and there towards the teacher while he is being teaching. So what we do, we have kept an ideal matrix, like an ideal list, which would, so we are doing this with the help of the coordinates of the nose. So we are tracking those nose and like tracking their faces with the help of various features of the face. Currently main focus is on nose. So if that particular teacher moves, obviously the student's face would also move with respect to that teacher. So we have kept an ideal matrix. So that matrix is also updated after a certain threshold of frames. For example, initially in first frame, that matrix was set based on the coordinates which were detected as the students are seeing forward, so that coordinates are detected. But if after a teacher moves, then the ideal matrix is also updated. Then the kind of deflection which is calculated is with respect to that ideal matrix. So that is also updated so that kind of we get accurate and precise results.
Okay, I'll park my questions for later. Right, I think the rest of
Okay,
the
sir.
kids have a lot more questions. Nilakanthan sir.
Okay. Okay, it was a good idea anyways. So congratulations for that. My question is that, okay, as I understand it, you consider the physical position of the face as a matter of whether it is attentive or not attentive, right?
Yes, sir.
Okay. And the collective data you are collecting from all the students whose face position. Now, how frequently you take this data? It's every minute or every second or every hour? Okay, you've shown a
Yes.
graph, a dynamic graph showing the attentiveness. So how often this data is collected?
So currently, as of the we have tested it. I am doing it for each frame.
Each frame, okay.
Yeah, currently I'm doing it for each frame, but then eventually when the project progresses and we are available with more data, so we can do it after a period as well. Like for we can analyze frame and then we can kind of take a moving average of those indexes as well. So that is the kind of future scope where we would take the moving average for each frame calculation, and then we could kind of some see, this is kind of research. So this is kind of we would try this and then come up with this solution. So yeah, we can try. I think we have this vision to try this thing.
Okay. So my next question on that lane is it possible? Okay, do you have any plan to pinpoint a student who is constantly inattentive
No, sir,
in
we
the
don't
class?
have any plan. That's why I told that we are not targeting each individual here. We are
Okay,
just our motto is to evaluate effectiveness for the whole class and then kind of devise new strategies if effectiveness drops, teaching
okay,
effectiveness.
okay, understood. Now, say, considering the physical uh, position of the face or physical location of the face where the person is uh, looking at, probably looking at, in fact, how effective do you think is the measure of attentiveness?
Sorry, sir, could you repeat? I didn't get your question.
No, how effective? Okay, now you are using them. How the face is positioned. Okay,
Yes, sir.
how effective is that determining the attentiveness of a person?
Sir, see, when we were in the initial phase of the project, even this was a challenge for me as well to quantify the level of attention in a student. This is something we can understand, but to make it familiar to a machine, to quantify
Understood.
the level of attention in student was a big challenge for me. But then eventually the project progressed. So I think if we talk of a use case, for example, a student is physically in the class and he is like looking towards the teacher and looking attentive, but mentally he's not in the class. So that obviously our system can't detect. That is something that is a kind of thing that our system can't detect. But if we consider this metric that yeah, if you are looking towards the teacher, you are kind of attentive, you are looking towards the teacher and you are engaged in the classroom, then our system is pretty much good
Okay,
regarding that if we consider that
okay,
metric.
okay. Probably your earlier answer is an answer for this too, because when you take a 30 member class,
Yes, sir.
maybe 4 or 5 maybe seems attentive but not attentive, or all on the reverse, then okay, let me work out. Uh, then have you ever, is there any, do you have any chance of testing this results? That is, you have a class of 30 people and your system found that okay, it is a 95% attentive class or 90% attentive class. Do you have any idea of how to test the effectiveness of this result, how to test the accuracy of this result?
Yes, sir. So what we did was when we were doing this, we tested it on multiple videos. Then the camera is mounted in the class where it is facing the student, so that video feed comes to us. Then to do it in a more better way and more understand and more get involved with the accuracy, what I did was that I there were sessions planned for me, and I went in the classrooms, and I used to sit at a kind of side corner where I observed the whole class, and the situation in the class was very organic, and it was just as a normal class where a teacher is teaching and the students are studying. So I used to sit at a side and I used to observe the class and behavior of the students, and how the teacher is like teaching and what is the effect it is dynamically having over the students. So I got that data. I observed that and realized that, and then I verified my results against the ground truth as well, like what is actually the situation in the class and what my system is giving, and then eventually we came up with this accuracy thing, I guess.
Oh, okay, thank you.
Thank you, sir.
Vishnu
Thank you
there?
so much.
Yes, yes.
Okay.
Actually, you are only depending upon the facial position of the students, right?
Yes, sir.
So, have you gone through any existing system?
Yes, sir. I searched about those gaze estimation and pose estimation things which are available.
Okay, being a teacher, I can say that we can't barely depending upon the facial position of a student to identify the attentiveness. Okay, we can leave that part. Anyway, is there any mechanism to find the sleeping student?
No, sir. As of now, it is not. But yeah, we can do that. For example, we can measure the eye aspect ratio of a particular student. If that aspect ratio is less, then the eyes would be closed. So that is again something that is in the future scope. But as of now, we are not. There is no mechanism to detect sleeping students.
Yeah, that's a problem. In most of the cases, we may think that they are attending, but maybe sleeping. So there is no displacement in face. So we can't identify whether he is attending or not. So that's a problem. And the second thing, you are considering each and every frame. How many classes are there in your college?
Sir, around uh, it would be around two, 150 to 170 classes.
Yeah, 150 to 170 classes. And if you are deploying the system in each and every classes, it will be very complex thing. So have you think about how will you consider the complexity or processing complexity when you deploy your system in all the classes? And I would like to hear from you the comment regarding the same.
Yes, sir. Yeah, that is a challenge that we also thought that to deploy the system in all the classes and to analyze and get those video streams which are coming from multiple classes is a big challenge. But then we are trying to solve this. So we can do that by means of edge node or edge computing. So that we can do. But since we have not done it yet, we have deployed for just two or three classes precisely before the lockdown. We were on the way to move it further as well, but before the lockdown we deployed it up to 2 to 3 classes. So that is something we have in our mind, and we can work on that. We are working on handling the complexity of different video streams and handling that in a very computationally efficient manner.
Okay, another question. It's not related to the effectiveness, but I would like to know what would be the remedial measures by analyzing these statistics.
For example, I can give you one or two examples. For example, if suppose there is data for first semester students, so we can see that the data is coming daily for a whole semester, and suppose we get to know that maths result, the result of subject maths for first semester students was pretty much bad. So we can look into the data. For example, a higher level authority, for example, a principal or a director who has to devise strategies can look into the data and then accordingly improve the effectiveness. For example, we can detect what are the peak hours of attention. So we can say ki, the maths class should be conducted in the peak hours of attention so that the learning outcome is achieved in a very fruitful way. So that's something we can do.
No, it should not be at the end or in the end result. So each and after each and every class, the teacher should know who are attentive or not. Okay.
Yeah, so we can do that with the help of dashboard. We would like.
Okay. 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 That's all.
Okay, sir.
Thank you.
Thank you, sir.
Okay.
Hey, Arpita, actually, I had some question, but the rest of the judges actually asked all of it. I know around sleep, and then if uh, how do you detect if a person is not moving just because he's not in the class, but he's just facing the teacher. That's it, right? Or he's staring at the board, right? And it will look like, you know, um, so I think it's worth exploring other means like comparing
Yes,
each
sir.
face with the rest of the face's movements, etc. And this can be some indirect measures, right? And it's a good job. I think it also is relevant in a lockdown kind of scenario, right?
Yes, sir.
Zoom and Team and all of it.
Yeah.
This mechanism to integrate that video feed. See, for example, what's happening right now. You see, Zoom is being streamed directly into YouTube, right?
Yes, sir.
So there are mechanisms like that could actually get your system integrated with something like that, and it's worth uh, exploring that option. And it could, if you have a commercialization,
Yes, sir.
objective, it might be a very good thing to try out. Okay,
Yes.
thank you. It was great work. Nice.
Thank you. Thank you so much, sir.
Okay, thank you.
Thanks for listening.
Thank you.
Thank
Thanks.
you. Thank you so much. Shall I leave the meeting?
Thank you, dear. You may leave now. Thank you.
Okay. Thank you, ma'am.
Judges, you may move to the discussion room. And the next presentation will start at 10:30. Hi, Rohan. Is everybody in from your team?
Yeah, most of us are on our way. I guess 3 of us have joined. The last one is coming. Yeah. Hey.
anyway, I'll give you some introduction. So out of the 30 minutes allotted for the presentation, you have 10 minutes for presenting, 10 minutes for the demo, and the remaining 10 minutes is for the question and answer session by the judges.
Okay.
Okay. So if you have any problem with the bandwidth, please please do turn off your video.
Yeah, sure.
And
I have a good internet. I'll share my screen. I guess the rest of the people, if they don't have internet, they'll switch off the videos.
okay, and only unmute when you are presenting. Okay.
Okay. So Viren is here.
Okay. Just a second. Now we have the third team on our schedule, which is from PS Modern College of Engineering, Pune, Maharashtra, presenting their project on the topic facial expression synthesis using voice tone analysis. All the best, team. Go ahead.
So I'll start sharing my screen now.
Okay.
Is this visible properly?
Yes.
Yeah, it's visible.
Yeah, so our project is facial expression synthesis using voice tone analysis. The main motive of our project is to automate the facial expressions for various applications. So we'll start with the basic problem definition. I'm waiting for Chaitrali. If she's here, she could start.
Yeah, I'm here. I would like to start. Good morning, everyone. We are here with our project, Facial Expression Synthesis using Voice Tone Analysis. The basic motive of this project is traditionally the keyframes were generated and those intermediate frames were filled in and rendered to create animation. And then this traditional method was replaced by manual process of capturing the facial expressions and emotions from a human actor and transferring it onto digital avatars. But this all was a very tedious work and it required a lot of time and manpower. Also, the human actors was required to be present at the studios for video capturing. So there are also some of the automation lip syncing processes available presently, but they need a transcript version of audio which makes it language dependent. So we in this project we have come up with a feasible solution which will be elaborated to you by Rohan in the next slides.
So basically, the problem that we are solving is that the facial expressions that are required to be synthesized in modern animated movies or games, or even for the digital counterparts of assistants like Google Assistant or something. If you have to provide a face for it, then you'll need to require give the facial expressions for the same. And the current techniques, as Chaitrali mentioned, were not to the point. So that's what we are solving. So we propose a solution where we use deep learning and convolution neural networks to directly predict the facial landmarks. That is the certain points, the coordinates of certain points on our face from raw audio. So our system works on raw audio, making it completely language independent. So you can use it for anything like Chinese, Japanese, English, whatever. So, and no transcription of the is needed either. So that is the main advantage of our projects. And also that the video that we are rendering can be rendered in as high as 60 frames per second, making it highly efficient especially for games where a high frame rate is required. So the implementation, we'll start pre-processing. Viren, would you like to start?
Yeah, I would also like to mention one other thing is that the main importance, like the main factor which separates our project from already pre-existing solutions is that our project only requires a 2D video. Like whereas it was mentioned before by Chaitrali and by Rohan that a very high-tech video capturing equipment is required by the various actors. For the various actors whose facial expressions are captured, those actors need to be in the studio for countless amount of hours, and also that equipment, which is very expensive, needs to be rented. So a solution to this was we have actually made this whole project around such video that it can be captured by any ordinary camera, who gives like even at least 30 fps, which is very trivial right now in today's technology terms, like which is very like any random video capturing equipment will give you 30 fps. And also it is just like it works on plain 2D, like no 3D video capturing equipment is required. So yeah, that's aggregate is quite a bit. Okay, then I will start on pre-processing. As you can see in the slide, we first start from the raw audio. Okay, this audio is segregated into windows. Now, these windows are of a length of 512 milliseconds. So the raw audio is basically divided into small parts of 512 milliseconds. Okay, then DC shift. DC shifting is one of the very basic or common procedure in audio processing, where if there is any noise present in the audio data, it is removed through DC shift. So what basically happens in DC shift is that the entire audio window or the audio frame is moved across its mean on the x-axis. So like if there is any noise or external points in the audio which is not intended to be in there, so they get removed through DC shift. Then in Hanning window.
Yeah. So Hanning window. Now if we consider a wave, the phenome that we need to extract, or the lip sync that we need to generate, should be for the center part of the window, right? Because the rest of the part are either the previous or the future sections of the window. So to amplify the central portion of the window, we are applying a Hanning window over it. So basically, a Hanning window is like a curve. Wherein the center parts are given a higher weightage, and the parts towards the end are like tapered. So if I could show it to you. Yeah, so this is like the Hanning window. So if we apply this over a normal wave, if this is an audio wave, the center part of the window would be amplified because this is multiplied with this. So this will be given a more weightage than the rest of the section in the audio. So we take out the important sections from the window. And then
the reason we do this is because our 512 millisecond audio window actually is split like into past, present, and future. So the exact in the 256 millisecond, it is supposed to be the present, like whatever your face or the audio is saying, or the face is implying, the emotion or the lip syncing is supposed to be shown on the 256 millisecond. All the future 256 millisecond part is of the future, and the rest of the part is of the past. So the reason we are doing this is because while we are like helping our model to like get a hang of what is happening, we need to teach it some like smooth transitions, like from which pose a certain face generates to the next pose, there needs to be certain transitioning. So the model needs to learn from this past and future samples how to transition from one pose to another. And then the reason we are using Hanning window is because while the model is processing this particular, say an X windowing frame, we need to give emphasis upon the present of the audio frame, because that is the exact pose which it is learning right now, and the rest of the audio software just help in for the transitioning of the smooth transitioning of the lip syncing.
Yeah. So the next part is correlation coefficients. Now, whenever we are speaking, like we want to extract the phenome from that to produce the lip syncing and next stuff. So for that, when we are speaking, we to produce a particular phenome, a certain section of the wave is audio is repeated after a certain interval of time. So what correlation coefficient does is we extract the time frame for which by which the segment is repeating, from which the phenome can be identified later. So that is the main part of the main purpose of correlation coefficients. Then moving on to the model. Our model is split into basically two parts, the formant analysis network and articulation network. So the first one, formant analysis network, is responsible for extracting, as I said, extracting phenome, that the major phenome for lip syncing from the correlation coefficients. And the articulation network is responsible to like drive the animation of the face, like of the eyebrows or of the mouth from the phenome that is extracted. So these are the two main parts of a network. Viren, could you explain a bit more about this?
So what happens in format analysis network is that the main lip syncing part is, as Rohan said, is done in the format analysis network, where the rest of the features of the face, like how wide or how raised your eyebrows should be, how wide your eyes should be, or like how your particular face should look overall, is influenced by the articulation network. So to help that, we have classified the emotions which we get through a data set into an e-dimensional vector classification, and we provide this data to the articulation network. So like in the articulation network, this data which is got from the e-dimensional vector classification is appended for the each network. Like there are 5 layers in the articulation network. So for better performance, or for the model to better understand like the emphasis of those emotions, it is appended to not just one time, it is done for the each network. So like every time the output of one layer is given, we just append the same vectors to the previous network. Again, this is repeated for 5 times, and in the end we get our result, which then so in the end, we basically get 128 points. We get 64 points, 65 points, each of X and Y axis. So we get 130 points in totality. And then we go ahead for rendering, which Chaitra will explain.
So, and the another part for e-dimensional vector is that just phenomes are not an effective way to drive the facial animation of the whole face, because mostly the eyebrows are not related directly to the phenomes, but they are related to the emotion that is in the current audio. So that's why we are using the e-dimensional vector classification, where the emotion is appended to the network, as Viren said, so which improves the facial animation part of the R network, and the phenomes are used for the lip syncing part. So the next is rendering, for which I had asked Sujal to explain a bit more.
Yes, so what happens basically is, first of all, e-dimensional vector classification classifies 7 emotions, and after that, actually it is given as an output to articulation network. So during training process, the predicted landmarks and the actual landmarks are compared and losses calculated. And Rohan.
Yeah. So in the rendering, as Viren mentioned earlier, we are predicting 65 landmarks in 2D space. So that gives us 130 of total coordinates. These coordinates need to be mapped onto a digital avatar, right? So if we have for that, a rigging is necessary. So we rig from our landmarks to the actual facial model in this rendering, the first part of rendering. The second part of rendering is actually generating those frames according to the landmarks that we are doing. And the third part is actually rendering the video. So the first part, actually, where we are rigging, there are different types of rigs and that are available, which Viren will share a bit more about.
Yeah, so we will see in the future video, which like the demo video, we have shown only one rig, but there are full rigs already available. And if a person, like, obviously there needs to be some customization, like only one face cannot be there in all the movies. So you can actually customize those rigs or those faces, but a professional CGI artist would be probably required for that. So what we have done is just use a pre-existing rig for that currently.
Yeah, we are using an open source rig called Vincent Rig, and we are using Blender, open source software called Blender, so that it is available for everyone. And the output of will be a final video that is rendered, depicting the facial expressions. The CV landmarks that you can see here is our dataset, CV dataset, which we are using to compare our predicted landmarks with the actual landmarks, as Sujal mentioned. So this is just the description of what we just explained. So I guess we can skip this now. Technologies, Sujal, can you? I guess she's on mute. Okay, I'll go ahead and explain. So the main thing that we are using is convolution neural network. So both the networks, the format analysis network as well as the articulation network, are different forms of convolution network. The first audio pre-processing, as we mentioned in the earlier stages, all the pre-processing section, the left complete part, that is required for in audio pre-processing, and that is a lot of pre-processing work to do. So that is audio pre-processing. And rendering, the actual rendering, as we mentioned, we are predicting points in 2D space, but those can be mapped onto a 3D rig as well. So yeah, that's why we have mentioned 3D rendering, because the 2D landmarks can be visualized into 3D by the rigging method that we are using.
So the reason we have
That
done this is that if you think currently, like if you are imagining an 3D avatar for say for Siri or for Alexa, currently you're just imagining a 2D space like a screen in front of you right now. So just 2D would be sufficient. But for in future purposes, well, like even currently the holographs are being used. So like for that, a 3D or something which is 3D would give much better effect who's interacting with you than just a 2D screen. So that is why you can also render it in 2D as well as 3D. So you have kept this in mind.
as required. So the platform we are using is Python, mostly Python 3.6, TensorFlow with Keras backend for the main network coding, and Blender is, as I mentioned, is open source software for rendering. Then a demo. So I guess we can divide the demo into certain sections. Should we run the actual project and show you, or should we show you the already rendered video that we have?
Yeah, you can show us the pre-rendered video first, and then we'll go over it.
Rohan, show the video from the video which we made for CSI. So there is a comparison between the data set and the, if you can, the actual video.
Wait a second.
If that's possible.
I'll play this for now. The main video.
The menu is herring. Death comes by train, a strongly evocative visual image. Then you would you.
Does society really exist as an entity over and above the agglomeration of men?
One look down on a sea of leaves, a breaking wave of flower. We will achieve a more vivid sense of what it is by realizing what it is not. Obviously, the bridal pair has many adjustments to make to their new situation. Both the conditions and the complicity are documented in considerable details.
The prospect of cutting back spending is an unpleasant one for any government. The diagnosis was discouraging, however, he was not overly worried. Those musicians harmonize marvelously. The Eastern Coast is a place for pure pleasure and excitement. It's one of the rare public benches here on which nearly everyone has agreed. No manufacturer has taken the initiative in pointing out the costs involved.
But this doesn't detract from its merit as an interesting, if not great film. He further proposed grants of an unspecified sum for experimental hospitals.
So that was the predicted video by our network, which was rendered in 2D space. I'll just open Blender to show you a bit more. So the video that you just saw was a 2D rendered video, but the character or the rig that actually we are using, this is the Vincent rig, and this is a completely three-dimensional rig, as you can see. So this can be rigged in any possible view that you would want in your game or the what you can say, the movie or anything. Yeah, and the reason we chose the front end part was the lip syncing was most clearly visible there, and also for if we consider digital assistants or something like that, most probably the front view would be required. But if required, it can be rendered in any of the like views as needed. So this is the Vincent rig. If I'd like to predict it for the actually render the video for one of our audio. So
that's required, like we can do it for you, but so we have just chosen a very small clip of 4 seconds. So that would be quickly.
Yeah, it would be rendered quickly. So we just chose a smaller clip.
So also I'd like to mention that the reason the video is appearing very choppy is because of actually the streaming process. The video is actually a very high 60 frame rate per second speed. So you can check how easily or how similar it is to the data set through the video which I've already submitted to you. So what I would like if I could make a suggestion, what I would like to say is that if you pause the video, like the video of which is in comparison with the data set and the actual rendering video, you will find similarity, like the lip movements, the closing and the opening of the lip movements is exactly the same. And also, like, obviously this is just the testing part, so it has not been included in the training data set. So like,
Yeah, so the one we predicted right now, the test loss was 0.03, which gives an accuracy of almost 98%, 97%. So we'll render this video now. As I said, the rendering carries out in 3 phases. The first part is mapping. So I'll start the mapping now. We can select. Okay, let me just. Yeah, so as you can see, this is the face. I'll start the mapping. It will the frames that we predict, landmarks that we predicted would be captured here. So as we mentioned, the rendering that is to be done has a very high frame rate. So that's why the rendering is like
a bit time consuming. So like, if you decide, you can just skip like even like you can take the 4th second, like every 4th frame for the rendering, so that will like just shorten your time by the 4th. But yeah, it won't make much of difference to the human eye, because like 60 frame rate, 60 frames per second is pretty high. Even 15 frames per second is pretty good, is what I think. So we have done those renderings, but we wanted to have the highest quality, so we have chosen to show you the 60 frame rate per second, right?
And this is, yeah, as Viren mentioned, this is a high frame rate rendering, so it takes time. If we chop it down, it can be done in real time for digital assistants as well, so that wouldn't be a problem. And as we go on, we can see in the animation section, the keyframes are being added, as you can see. And now we'll render these. So 124 frames have been generated, and we'll render it to a video. So that is the second part. We are actually just captured the moments, captured the landmarks and the change in landmarks and generated the frames. And now we'll render the video. Yeah, so basically you can see the same thing, but here actually video is being stitched together from the avatar. So what we saw was in 3D, the capturing was in 3D, but we are rendering now in 2D. So we can change the view in this part. Yeah, so here if we change the view that we want in another dimension or something from a side view or something like that, and then if we render, we'll get the side view as the video output as required. So basically in movies or something, the poses of the face are pre-estimated by some other animators who actually are deciding where the body goes or how the body is moving, and that can be integrated directly to this using Blender. That's why we chose using the tool Blender instead of using our own Python scripts for these renderings, so that actual animators can use this for in movies or something like that. So we are at 65th frame, and the total is 124 frames, so it'll take a bit of time. Till then, I could explain. So yeah, so this is the main network, our network. As you can see, the first part, the formant analysis network, in that we are convoluting down to the second dimension, as seen, sorry, the third dimension. So here, if you see 16, it is getting reduced down to 1. So this one is the predicted phenome by our network. And we are using this phenome according to, and then using it to predict the facial landmarks. So in the next phase, we are boiling down the emotion parameter to 1 and just increasing the first parameter, which are the actual coordinates of the landmarks. So here in the next section, if you see, everywhere it's 1. And
if you notice over here, at certain times, the number on the leftmost side is 263, but it is getting increased by 7. This 7 is the emotional vector output, which are adding to after each layer.
Yeah.
So like the network, like after every layer's output, like it inherently learns what we're trying to teach it. So like it's not appended just one time, but it is appended like almost 5 times. And after that, you get to the final reducing through a fully connected network of 130 points.
Yeah, so this is the 130 final outputs. The video has been rendered. I like to play it now. I guess it's in downloads. Yeah, so these were the frames, as we mentioned earlier, containing the actual landmarks. These landmarks are predicted by our network, and those are the positions with respect to the central point of the face. And those were captured and rendered using Blender. So I guess the video should be right here. Rendered videos, yeah. So this is the video that we just rendered.
She had your dark suit in greasy wash water all year. She had your dark suit in greasy wash water all year.
Yeah, so that was the rendering, the actual demo of a project. If needed, I can play the video back again. What should we do?
So if you have any questions regarding our project.
Regarding the demo, if you have any questions, you can ask it, or we'll move to the future scope.
Please go ahead.
Yeah, okay, sure.
So
as you saw in the rendered videos, the main thing in our project is that downside of our project is that the eye movements are not changing. Like for facial expressions, the eyes should also change according to the emotion. For example, if you're feared, your eyes should be open a bit more, and then for a neutral position, your eyes should be half closed or something like that, because that's how we actually that's how the facial expressions are while we talk. So that we are planning to add. We are using 65 facial landmarks that were provided in our data set. Just a second.
Another thing which we are
so these are the landmarks that we are using, 65 landmarks. But instead of along with these, as you can see, there are no points near the eyes, so we couldn't render the eyes. But we are currently working on taking the eyes from the 68 landmarks, facial landmarks that can be extracted from the video. So for that, the opening of eyes can be changed or altered using these landmarks. So that we are working on currently, and that is.
Another future scope is that as this project solely is based upon the audio of the person, every person's way of speaking is different. Every person's intensity which they express.
Would you explain the second thing?
Is my audio not audible?
I guess you're on mute.
I've unmuted.
No, we're able to hear.
Hello. Okay. So another future scope of a project is that as each person's intensity of portraying the audio or any emotion is different, there is a certain amount of tuning which is required. If a person usually overcompensates, if they're angry, it is really evident from their voice, then we need to just subtune our parameters a bit low so that it is not exaggerated in the video. On the same hand, if a person is very meek while talking, like they don't express much, or if their voice is very flat, we need to enhance those features. So what we are hoping we could do in our project is that this tuning is currently has to be hand in by us right now, analyzing the video. So what we are hoping to do is that the network will also be able to hand tune these parameters by itself. So like no manual work would be required absolutely at all for it to be done. So like a person can just take a camera, just shoot themselves, just put those audio clips inside, and that the model would be working just fine.
Yeah, so that is for training. If you want to train on a custom audio, as Viren mentioned, just for predicting on the existing model, you don't need to.
Yeah, you don't need to do anything as such.
So that's it from our end. If we are open to any questions that you might have.
Yeah, thank you for the presentation. Can you summarize your entire project in about one sentence of about 20 seconds?
Rendering the facial expressions from raw audio, which is multilingual, for digital assistants and animators.
Right. So basically, you're using Blender's Python, embedded Python scripting to do this, right?
Yes.
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 Okay. What was the toughest part of this project?
Actually, the domain knowledge that was required for the pre-processing of audio and the yeah, so that was the hardest task for us because we were not too familiar with audio processing, but we learned on the way. And
so were you using Blender earlier before this project for anything?
No, I have not. Only for this project I have used.
I'm asking this because I've been using Blender for the last 6 years.
Wow.
So yeah, so now as far as the output of your project is concerned, my first comment is that you have left out the eyes, which is supposed to be the most expressive part of the face. That to me is very puzzling because if you're supposed to emote, then the eyes would be the primary candidate for that expressing your emotion. So what do you think is the reason for this?
Actually, the data set that was available for us, we searched quite a bit for the data set. So the only one that was available, as I mentioned, had the
65
didn't
landmarks.
have any points near the face, near the eyes.
No,
so
but
we couldn't have any.
That is supposed to be your contribution, right? You're supposed to kind of be contributing to the project. So that would have been an advancement if you had, kind of incorporated eyes as well. That would have been really a kind of innovation.
Yes.
Yeah, so actually we did start with it. If you can see, I have the landmarks. Yeah, so these landmarks that you can see in this folder are the 68 landmarks, which we have already extracted and are ready to use. The problem that we were facing in the past couple of weeks was that the coordinate system that is used in this particular data set and the coordinate system that is used in the 68 landmarks is completely different. So we had to find a mapping function first. So we have done that and we are introducing the eye functionality soon. But yeah, as of now,
it will happen in a bit, but it is not currently ready right now.
Yeah, I'd like to request my colleagues to kind of ask further questions. Any other questions?
No, from my part, I have no.
Yeah, I'll go ahead and take some questions. Right, so hey, if you can share your screen where you had the Keras model displayed, right? And you talked about one layer with only single node, single unit, and then at the end you also showed something which is 130 unit.
Yes, sir.
Yeah, so the first part of network, as you can see, it is a convolution. So the 16 was reduced down to 1. Okay, so that was the part of as we mentioned, the formant analysis network where we are extracting the phenome. Okay, so that the 1 signifies the phenome. And the next, from that phenome, we are boiling down
when we are saying phenome, we're talking it translating to some facial expression, something that has to do with
phenome,
phenotype,
like
something
so
to do.
phenome, actually phenome, the better word to say phenome is that it's basically simply lip syncing. So what yeah,
the pronunciation for that particular
how can you summarize that in one unit?
Yeah, so basically for a particular frame, you'll only have one phenome, right? The one kind of pronunciation. Like if you select a 512 millisecond window for that, and if you're saying k, for example, then only k would be the dominant phenome in that. And we, from all the audio that window that we have, we want to extract that k. So that is done in a phenome extraction. So that's why we are boiling it down to 1.
Okay. I think it's the dimensions are a little different. I think. Okay, so you
yeah,
also use
concatenate.
So you use concatenate, which means that you have, or is it just the name? I don't know, but it looks like you merged multiple networks, right? What is the purpose of it?
Yes, sir.
Actually, as we mentioned, the emotion parameters that we are using is appended after each layer to amplify the emotion, the factor that emotions play in the um, emotions play in the part of and facial
Like just
expressions.
simply portraying. So like
Those are the concatenation layers where we are concatenating the emotion again with the previous layer's output.
what we found that instead of just appending it once, which is what usually must like it is usually done, like just you can just simply take a 26 like a 270 network of having 270 points and then just rendering down to 130. What we thought was that, and also it give better results, that if you add the same emotion parameter after each layer is done, so it gives even better results. So it is like evident in the like even smoother transitioning and vivid expressions. So that is why this is done. Like, so we are conjugating the same seven, the same layer each time. So the seven is just the emotions, but it is just not the number. So like it is a whole 64 by 32 autocorrelation parameters and everything is
Actually, I have a video that is rendered without the like only where the emotion was appended only once. If you want, I could show.
No, I think since we have very limited time, right, and there are two more
yes, sir.
panelists who have questions, I will kind of cut short. So now at the end you have 130, so
Yeah.
130 units,
yes, sir.
right? And what are those? Are they facial landmarks? What does that translate to?
Yeah, those are 65 facial landmarks and 130 is 65 into 2 because in the it is the landmarks are in two coordinate systems. So x and y coordinates for each landmark.
Okay, so now so that's what I guess, and what your model generates is that frame.txt or something you said. You basically had the coordinates there, right?
Yeah.
And so you said it was difficult for you to get details. So I understand that this is about audio, and lips are most important aspect there, right?
Yeah.
But like Satish sir said, eyes is something important, right? And you said there was a lack of data, but that could have been done, isn't it? Like if you use DLib or darknet models, right? That could have helped you extract. You could have created your own data set. Was that difficult, or did you try that?
Actually, the extraction part was easy. We, as I mentioned, we have already done that. But the mapping and the basically the systems that were used in the dataset and this were completely different. So we had to the facial like the coordinates that we got were totally different. So we had to.
I got that. No, with you had video files associated with the data set that you got as well,
yes,
isn't
sir.
it? So you could have, would it have been difficult to actually extract facial landmarks specifically to do with eyes?
So what what
So what
happened
we
was that if you look at a face, the point which almost doesn't move or doesn't move at all is at the tip of your nose. So like you can do whatever expressions you want, but it won't move. So that is the reference point which you have used for the data set. So the problem exists that when you're trying to inculcate those eye movements, which is part of the 68 data set, if the Rohan can show you the image, which is the part of the 68 data set data point stream. So there is a problem that if you can notice, there are 3 points over there, 30, 31, and 34. And while on the other hand, if you look at our dataset, which you have used, which is a 65 dataset, there is only 2 points, which is 30 and somewhere between, yeah. So that is the problem. So like the problem is selecting a reference point. If you select one proper reference point, there is not a problem at all. So that is all we have to figure out, that which will give you which will give us the same results which we are getting right now, which we are really happy right now. So like we don't want to again get into the networking part. We just want to figure out which will be the best frame of reference shift. So like we can easily shift from this.
So what we are doing right now is taking the rest of the facial landmarks from our data set and just taking the eyes from this. And we have done out the mapping part. Now we have to work on training the different models.
Yeah. Okay. So, but yeah, what you said was we could try what you said. Like we could use an entirely different method like DLib and maybe just use a completely different network and then merge those two networks to form some rendering.
That's right. So can you elaborate on e-dimension vector classification?
Yes, sir.
What you done with it?
So what in our data set, we got videos which were already pre-labeled. So that helped the entire process. So what we did was that we just did one hot encoding. So for example, if a video is saying that it has sad features already throughout in it, as we're segregating each videos into different frames, we have basically one hot encoded those 7. The 7 is like neutral, happy, sad, anger, and the various other emotions. So if the video is saying it is happy, then we are just one hot encoded happy into all of its frames and giving 0 to the rest of the features. So this is how the network inherently learns whatever like the emotion which is being tried to portray, like as it is getting different parameters for different videos which are differently classified. So that is how e-dimensional classification works.
Okay. Okay. I think that's it. Uh, and what do you see are the commercial, application? Do you realize that this could be a? What do you think? Is there a market for this? Um,
So if we consider the current trends like assistants or something like that, if we see Google Home Hub, so they have like a digital assistant with a display built in, and if we could something implicate or use for it for those, then the visual counterpart would be more interactive for the user, because right now it feels as if you're speaking to a box, but the digital would be the face would be like it would feel more interactive and intuitive.
And this saves a lot of efforts of all those animators who generally just use it for just animation and gaming. So like
Absolutely. So it is a very cost-intensive industry.
like initially people used to just draw it by hands and then scan it and everything, and then again some
And one
technological
more thing is
reforms
that
have been done, but
if
still
we
this is
consider the
very
Japanese
cost effective.
animation
Like
industry, right?
Fantastic.
In the animation industry, Japan is very forward if we consider, and for that, uh, the lip sync that we are generating can be used for Japanese language also, because it is not language dependent on any
it's not
language.
language dependent at all.
Got that.
Yeah. So other technique.
I think I will wrap up because the other judges have. But I think this is having immense, commercial potential. One of the biggest problems is, people have how they want it to happen, but when it translates into an animation, it's not there, right? And if you give them power of repeating this and doing trial and error quickly, right, without the pain of time required for animating or physically setting up stuff, right, that has big value. And this just definitely has immense commercial potential, specifically in the animation world, right? And all the companies are moving towards it. We've already had many animation companies coming and asking us, hey, I want AI to do things like what you're saying, and movement of leg, like drunkard walking. They want a library of those kind of things, right? So this is having big potential. Adobe, for example, right? When from as basic as 2D pictures, filling up content to higher end animation, all of those companies are moving towards that. It has big potential. I think should continue doing this fantastic work. Thanks.
Okay, thank you.
Thank
So
you,
I
sir.
would, if I may, just one more point. Will be very short. So as we have said that we are not using like no NLP is used. So if you use, say, for example, a word "not" is there. So what generally would happen is that the expression would suddenly change into "sad," but that does not happen because we have inculcated such loss countering techniques which we are usually use, so that it gives a feeling of pseudo context analysis while none of it is being used. That is also the reason. Also, it is.
Right.
Language
Thanks
dependent.
for that. We are running out of time. So I
Yes, sir.
suggest that just one of you speak at a time. Don't all of you jump into speaking because we can't make out what you're saying. Yeah. Any other questions from any of the judges?
No, I don't have.
Right.
No.
Okay. So I think we will wind up here. I had one more question, but we don't have time to take it. So thanks very much for your presentation and for your very interesting work. We will get back to you.
Thank you so much, sir. Thank you.
Thank you, team. Now you may leave. The
Thank
judges
you.
can move to the discussion.
Yeah, sure.
I think we're all getting a little hungry. So let's have a short tea break. Go grab a quick bite and a cup of coffee and be back by sharp 11:30. The next presentation will start at 11:30. is back. The CSI InApp NASA Student Project Awards is an annual event that involves a 6-month process, starting from the call for applications to several rounds of evaluation. This year, we had a little over 2,500 students from across the country, representing 96 colleges with a total of 571 projects that were presented. Further to this competition, we feel it would be very useful and appropriate for a large number of enthusiastic students to gain insight from rich interaction with accomplished people from the industry as well as academia. Therefore, it would be a pleasure to announce a 3-day webinar series starting from July 2nd to July 4th. Topics like entrepreneurial, data science, biomedical engineering, and bionics will be discussed by eminent speakers. We are also planning to host a panel discussion on the topic Reimagining the Future of Education with eminent panelists who are pioneers in their game. Hi Aditya, is everybody in from your team?
Yes, ma'am, everyone is available.
Okay, we have 10 minutes for your presentation and 10 minutes for the demo. The rest of the time is for question and answer session. Okay, just unmute yourself when you while you are presenting. Okay, now let us see the presentation on the project Securing EHR using blockchain by team from Lakshmi Narayan College of Technology, Bhopal, Madhya Pradesh. Go ahead, team. All the best.
Hello, am I audible? Hello.
Yeah, we can hear you.
Hello, am I audible?
Yes.
Yeah, go ahead.
So good morning, everyone. Here I am Gaurav, and I'm here to explain our project titled as Securing EHR using blockchain. So let's move to the problem statement. Let's suppose a real life scenario. Let's say there is a patient and he's suffering from any disease. Say, like he's suffering from stomachache. So he went to any hospital for his checkup. There the doctor prescribed, the doctor done some checkups and prescribed him some medicines. Now he came back to home and he's feeling way better. But again, after let's say 2 weeks, 1 or 2 weeks, he again developed some disease and he went to another hospital. But there the doctor asked him there the doctor asked him about his previous medical records. But let but there may be a case that patient may forget to bought his previous medical records. So hello, I'm audible.
Yes, please go ahead.
Okay, sir. So maybe there may be a case that patient may forget to bring back his previous medical records. This may not be a big issue, but in some situations, this may prove to be a fatal because doctor may need his previous records for his current to understand his current health situation. So these are some type of problems that our current healthcare system is facing. Also, there may be a problem that the patient's data has been compromised, or there may be a database breach in the hospital's database. We can ask following questions from the current healthcare system. That is, how one can see information in his records and make sure it is correct. Is it protected from loss, theft, and hacking? What one should do if he thinks his data has been compromised. These are the major security vulnerabilities in our existing EHR system. So let's move to the solution part. Okay. So, so if the medical data of the patient would have been kept in a decentralized manner securely, which can be accessed by hospital by with the correct credentials, then the patient would not have been suffered and his treatment experience would be much better. So there is a need of solution which can connect multiple hospitals and their databases, but without compromising with the patient's data security and patient's anonymity. So this is the main idea of our solution. Here we propose a blockchain-based architecture for our solution. So since blockchain technology has the potential to transform the healthcare, placing the patient at the center of the healthcare ecosystem and increasing the security, privacy, and interoperability of the data. So using blockchain, we will store the patient's details on the blockchain and patient's health records on a distributed file storage, that is IPFS. We are using here IPFS. So from the next slide, my friend Aditya will explain you about blockchain.
Hello everyone, am I audible?
Yes, you are audible. Fine.
So now let's see what blockchain in general is and what were its main features that draw it towards itself, so that we have used blockchain for as a potential solution to our problem. Blockchain, more than just a technology like cloud computing or machine learning, blockchain is a genius concept. It is like an idea it is a pure genius idea. It is like a data structure that can be implemented using any language. Blockchain is very general, is a continuous growing chain of blocks or records. And these records store our data according to our need. Like in our case, we have stored a patient's data on the blockchain, which was our need. And these records or the blocks are connected to each other securely using cryptography. We can say blockchain is a distributed peer-to-peer network where each peer have the same copy of data, store the same copy of data. Now, talking about the main features that made us to use blockchain are, first of all, blockchain is distributed. We wanted our patients' data to be distributed, and thus blockchain provided us this facility, so we have used it. Secondly, we wanted that we should not compromise with the patient's data and its security, whether its data patient data should be secured and it cannot be hacked. So since blockchain is immutable and the blocks of the data once written cannot be tampered or cannot be hacked, so blockchain provided us this facility also. And so the we achieved that we achieved that the data of the patient is not compromised at all. Blockchain is like a distributed peer-to-peer network. Gaurav, please go to the next slide. Okay, so here we have used Ethereum blockchain as our main blockchain. The reason for using the Ethereum blockchain was that we wanted to create a decentralized web application, and it was Ethereum providers as that way because we wanted the hospitals that are going to be a part of our network can interact with our decentralized web application without actually knowing the facility, without actually knowing what the blockchain in the deep side is doing. So Ethereum provided us that way. We have built our web application over the Ethereum blockchain. Also, Ethereum blockchain provided us a feature of smart contract. Smart contract are nothing but these are pre-written code that can be deployed on the blockchain, and these contracts can easily automate things for us on the blockchain. Uh, Once these smart contracts are deployed, they have the capability of changing the state of the blockchain if the events or the functions of the smart contract are triggered. These contracts, when deployed on the blockchain network, these reside on the blockchain. So, Gaurav, please show the patient's smart contract that we have created for our application. So here you can see we have created a smart contract called patient. This smart contract is wholly responsible for doing the stuff on the blockchain. This act as a middleware between the actual hospital and the and the blockchain, because this takes the data of the patient from the hospital and stores it on the blockchain, and also stores on the IPFS. Go to the IPFS slide, please. Okay, so one drawback we can say of blockchain is that the blocks here are of limited size. We can only store around 1 to 2 MB on the blockchain, on the blocks of the blockchain. So it was almost impossible to store the actual records like medical, like MRI or the doctor's prescription on the blockchain and then append it. Rather than this, we have used an interplanetary file system called IPFS to store the actual records of the patient. What IPFS is? IPFS is a peer-to-peer distributed file storage system. That the nodes in the IPFS store the actual data, and one record is never stored on a single computer. A hash table kind of something is created, and then a single file is distributed among the nodes of the IPFS. These nodes are controlled by us, and once the app is fully deployed, we will make sure that these IPFS nodes are actually the nodes of the hospital, because anonymously giving any node on the internet the right to store would be a compromisation with our patient's data. So patients' health records are stored on the IPFS. So this diagram shows how we have built our decentralized web application called MedApp over the Ethereum blockchain network. So once a hospital come and uses our med application, decentralized web application, he has to first sign up. Once he signs up, he gets the right to and upload data on the blockchain, upload data of a patient on the blockchain. Uh, he does it by doing with the help of smart contract. Smart contracts help the hospitals to interact with the blocks. The blocks store the details of the patient, and the interplanetary file system with the help of smart contracts store the actual records of the patient. This way we have created our whole application over Ethereum network. Okay, now my friend Susmit will going to explain about the technologies used and the future scope of our project.
Hello everyone, am I audible?
Yes, you're audible.
Okay. So in the front end, we have used HTML, CSS, and Angular framework. On the server side, we have used Node.js and the REST API for data sharing and service providing. Coming to the blockchain and the smart contracts, we have written the smart contract in the Solidity language and used the Ethereum platform as a blockchain. Through Web3.js library, we have made a communication link between the server side Node.js and the Ethereum platform so that they can share the send the data buff to one another. For storing the data for storing the hospital's information, we have used the MongoDB database, and all the other information, as Rajesh said, we have used IPFS. So here are the technology stack. So Gaurav, please change the slide and come to the future scope. To the future scope. So we have made the basic project, and what we are adding in the future is we can add features of video conferencing, chatting, and video calls so that different hospitals and doctors can communicate with one another regarding the patients. We can add fee payments, registration, and pre-booking for operations. And we can also show the number of doctors and the number of beds available in the hospital. We will show the nearby clinics and the hospitals in the city, in the town. Regarding advanced technologies, we will also like to add machine learning, as machine learning is able to predict. So we will add the columns of symptoms. So when the patient will add some symptoms in the column, so the machine learning model can precisely tell what is the disease and can predict the doctors and specialists as well. So these are the future scopes. And now I would like to say, Gaurav, that start the demo.
Here is our front-end server, which is Angular. This is up and running, and this is our front-end server, and this is our backend, which is written in Node.js. And this is the tool that we are using, which functions exactly as the Ethereum network. This is Kanashi, and this functions same as Ethereum network. And Here is the database. This database is used to store the hospital's
I think we
information.
are having difficulty hearing you. Is it the same with rest of the people on this call?
Hello?
Yeah, there are some audio issues. Maybe everybody else can mute except the presenter or the person who's speaking.
Now I'm audible.
You are audible, but it's patchy. Yeah, go ahead. I think the presenter is also muted now.
So now I'm audible. Hello?
Yes.
Okay. So this is Mongo database, and here this database is we are using to store the hospital information like that we take while while the sign up of the hospital on our platform. Let's move to the actual app. So this is a web app, and this is the homepage. And we have also added a chatbot to assist the hospital in when it might need any help regarding our platform. It it can assist the hospital, and these are the steps that hospital can follow. First, it has to sign up on our platform. Then it it can sign in with the private key and the email ID with which the hospital registered on the platform. Then it can register patients and simply upload their data on the IPFS. Let's see the actual demo. First, the hospital will sign up. Let's say the name of the hospital is like anything. Address is.
You have 3 minutes.
Okay, sir. Just a second. Contact number is this, and email ID is this. And in this field, hospital can choose in which department it works, like orthopedics, physiotherapy, and this all this. And after this, it will register. Now hospital has been registered, and a private key and public key of the for the hospital has been sent to the email. Now when the hospital will check email, I have so this is this email key, and this contains the private key and public address of the hospital. This private key and public address is assigned to the hospital when it registered to register on our platform. First, we also have to send some ethers to this public address which the hospital has been assigned, so that hospital can upload the patient's details and their health records. These ethers are like costs which has hospital has to pay to fund to do the transactions, like upload the patient's health details. I will just copy this public address of the hospital, and this is the tool which we use to send the ethers. Send ether. This is called as a MetaMask, and here we let's say we send 5 ethers to the hospital, and it's pending. So it's the ethers has been sent. Now hospital can upload any patient details and patient details. Now let's see the actual. Hospital has to sign in through this private key and the email ID which it used while registration. So I will copy and paste this private key here. Sign in. Now this is the dashboard, and here the hospital can register a patient. Like let's say patient is Gaurav, and this is the contact number. Aadhaar number is this, and age is 20, and this email. Now register. Now here the unique ID is provided to a patient. This unique ID is very important because through this unique ID, a patient can any hospital can access the patient data which is connected to our blockchain network. Let's say I will copy this unique ID for right now, and
You have 1 minute more.
yes, sir. I'll paste this email ID and this. Now the hospital can see the patient details after this. An OTP has been sent to the email ID provided while login. Uh, so this is the OTP. And so this is now the patient data is visible. This is the data which hospital put while registering the patient. Also, now right now there is no health records available for the patient. Hospital now here can upload the health record like these. These are the options that we provided like X-ray, MRI, anything. Let's say I select the X-ray. I also have a dummy files to function as X-ray. Like let's say I select this scan and I upload it on the IPFS. This will upload this health record on the IPFS. Now file has been uploaded.
Okay, please stop now. Thank you for the presentation. It's an interesting project, but your time management is seriously impaired. We have no desire to see your login and OTP and all that. We understand all this perfectly well. You should have focused on showing us the relevant portions of your project, the functionality of your project, not things like login and all that. Okay, I have several comments on this, but I will ask just one question before passing it on to my colleagues. I'm not sure if you're aware of data protection and privacy laws of many parts of in many countries, in many parts of the world, and India also now. In all this, the major focus is that the patient himself controls access to his or her records. Now, in your case, the patient has to hand it over to whichever startup or company that is running the system. That does not work at all. Because once the patient hands it over, he has or she has no control over the data. That is not the way things are going to work in future. That's one. And secondly, I saw something that is very intriguing. You have used the private key of the hospital as password. Now, this is incredibly wrong. The private key can never ever be used outside the institution. That's why we have passwords and passphrases. The private key is to be locked up in a safe in the hospital and only used for decryption of incoming documents. It can never be shared with any other person in the world. So I'm not sure if you got your fundamentals of encryption correct. And one final point, in your initial slide, you said loss of data is a reason why you have proposed the blockchain. So see, I can simply do all this with an encrypted database that the encryption key is controlled by the patient. Regular database, you don't need a blockchain at all. A database on the cloud is as secure with the normal problem of crashes or loss of data does not apply on the cloud generally. So if there is a database which is encrypted with the patient's private key, then the patient controls access to whoever gets it. So what are your comments on these questions?
Sir, on the last point, sir, I would like to say that here the hospitals when the hospitals are connected to the network that is the Ethereum network on the blockchain, then if any patient is registered on any hospital on the network, his details can be accessed by any other hospital, but only with the patient's consent. Like he has to provide that OTP thing. That's why we provided that OTP process in the middle, so that so for the data, for the patient's consent. So that's why this is the mean that we make the hospitals database like interconnected with each other.
Sir, I would like to answer your questions. So one of your question was you can private key and account number on the email. So what the actual reason is, actually want to transfer the money also. So somehow we have to share not share, but you have to provide someone private key and account. So that's why we have privately sent these details on the email. Yes, we are somewhere wrong that we cannot share even with the Gmail, but we have to unite those two things, that you have to create an account to share the money, and you have to create account that can privatize your account. So that's why we have shared on the email. And you said that database is also as secure in the cloud. But if many of the doctors are using the database as simple database of MySQL and other database. So if that crashes, that it will be a huge loss. So we have used the IPFS because that's secure and no one will actually analyze where the data actually is.
Okay, are you aware of the persistence problem of IPFS? You know what persistence means? IPFS uses a process called pinning. Otherwise, all data is purged during garbage collection. So periodically, all the IPFS data that you put on IPFS servers are flushed out, meaning they are
Yes,
destroyed.
flushed out. Yes. In the
Now
few time
you
it
have to
flushes
pin
out.
it. You know what is pinning?
Okay. Again and again putting on the IPFS?
No, pinning is not that. So that means you have not really used IPFS. Pinning means there is a separate command where some of the servers can be instructed to hold on to this data and not to garbage collect it. And that involves a payment. There is a money, or you can put up your own IPFS server and you can pin it on your own server. That in that case, it is free. So you are adding costs both on Ethereum. Every transaction on Ethereum, you have to pay gas. You've been testing on the testnet, right?
Yes,
But
yes,
if it's
in
actual
the
Ethereum, you have to pay for every transaction.
yes, sir.
And you have to also pay for the IPFS pinning. So IPFS is not a perfect solution. It's a solution in some contexts. I think I will defer to my colleagues for other questions.
I actually don't have any major question, but if you were to summarize in like 30 seconds or so, what is the decentralized aspect here that you're talking about? If you can just summarize that in 30 seconds or so.
Okay, decentralization here means that we are not saving any data on a particular server or not some servers. We are actually randomizing the data stored. So yes, IPFS is randomizely storing the data on any node, and the data and the transaction we are doing. So that also is added to every block in the node. So that's how our project is decentralized rather than on one server.
The patient details that the hospital uploads is stored using the smart contract. So smart contracts are not stored on like only one server. It is distributed on many servers, but that is connected to our network.
So does that give full control to the patient? Is the only question I had. I think I'll defer to the rest of the panel members.
Hello, I have one question to you.
Yes.
So, what do you, okay, otherwise, what would be the legal position of implementing the system in India as of now?
Pardon, sir, I'm not getting the question.
No, the legal position of implementing this solution, because in fact, your hospital is sharing their data or putting their data elsewhere.
Yes.
Which may be accessible. Okay. So, is there any legal hurdles on this?
Yes, legal. There is a legal ownership over this. That as you have seen in the project, no one is able to see directly the data. Actually, the data once OTP is sent to the patient. So when the OTP will be given by the patient, then only they can access. There is no such direct access to the data by the doctors. Once
Also, sir, which would allow the blockchain to be
No,
used
my
as
question is the legal provisions.
yes, like government should allow the blockchain to be used for the in
Yeah.
the life scenarios, like
Yeah.
because the blockchain is now still like developing technology. It has not been used majorly.
But you're not audible to me.
Hello? Now I'm audible, sir.
Yeah. Okay.
So the blockchain is still a developing technology. So there may be chances that government may not allow the blockchain to be used as a potential solution to store data right now. These may be the legal problems that come by while implementing this project.
Okay. Okay.
Hello. So you have sent the private key via mail.
Yes.
And suppose you are not using that method, what would be the alternative method? If we are restricting that, you should not have to send the private key via mail. Okay. So what would be your alternative method? So you have mentioned that some money transactions have to be performed.
Going through the account key and private key. Yes, sir.
Okay.
So, like we can create a separate separate app where hospital will register, and that app only the assigned private key and the public address will be visible to the hospital. Like we have the valid concept in the Bitcoin, like that.
Oh, that would be very complex. Okay. Okay. Thank you.
Any other final questions from anyone?
No, I don't have.
Nothing here.
Okay. We'd like to thank you for your effort, and we will get back to you shortly.
Thank you, sir.
Thank you, team. You may leave now. The judges can move on to the discussion room, and the next presentation is at 12:15. I would request the judges to turn on your video if you don't have any issue with the bandwidth while you are interacting with the participants. Hi, Pooja. Is everybody in from your team?
Yes, I believe everyone's in.
Yep.
Next, I would like to invite the team from Rajagiri School of Engineering and Technology, Kochi, Kerala, to present their project on the topic Automatic Clinical Report Summarization System. Go ahead, team. All the best.
Okay, so I'd like to share my screen. I'd like to ask the permission for that. Hello. Hello, sir. I'm not able to share my screen as it's already
it will be done. Can we?
Yeah, it will be done.
Yeah, okay.
So a very pleasant good afternoon to all. Here we are to share the key insights from our project, Automatic Clinical Report Summarization System. Well, what we would like to do is take you through a journey, what we experienced in making our model, right from the beginning to implementation to delivering our product. So yes, let's begin with. Well, it was in September 2019 that we as a team got to visit the Rajagiri Hospital. There we got to meet the head of the radiology department, Dr. Ajit, who expressed his concern about the increasing number of patients each day. Multiple patients with multiple reports, that was the main task. Multiple reports, that is the reports of different types like the blood reports, hematology reports, and so on. Well, reading all these reports one by one turned to be a very difficult and time-consuming task for the doctors. Well, what we as computer science engineers saw there was a scope for an ML-based system that could extract the key insights from the reports. To be more technical, extractive summarization tool. Our next aim was to come up with a summary, and we had a brainstorming session. So at first, we thought to come up with a pre-trained model, as in a model which is excellent in handling the NLP task. And our second objective would be to fine-tune this model so that it perfectly fits into the medical domain, so that our pre-trained model will have that particular medical edge. We wanted a model to be user-friendly. We would be aiming at two categories of users mainly. That is one, admins, and secondly, the doctors. Now, for admins, we were planning to come up with a Windows application. And for the doctors, we thought of coming with a web-based application. So yes, let's begin with the first point or our starting point, coming up with a pre-trained model. When we thought of it, BERT, bidirectional encoder representations from transformer, was definitely our first and the best option. Well, if you ask me why, with a very complex architecture with nearly 12 attention heads, 110 million parameters, BERT was excellent in handling the NLP framework. It was being trained on a huge data set as that of Wikipedia and book corpus with nearly 3,300 million words. Well, let's see what BERT does. It takes the medical report, which is our input document, and it breaks it into tokens. Now, each token would be each word. And what is the output of BERT is that it is a context vector for each word. Context vector, meaning that the meaning of each word is compressed into a context vector. Well, as mentioned earlier, our objective is extractive summarization. So we thought of a variant of BERT called BERTSum. Well, this is the architecture of BERTSum. Well, let me take you into what BERTSum does in a glance. Well, what BERTSum does is that it takes the output of BERT, the context vector of each words, and converts it into a context vector for sentences. That is, the entire meaning of the sentence is compressed into the context vector. Well, this was our pre-trained model. Now, so let me just take you into the design of our model. For this, I call upon Parvati to explain more about the design of our model.
Thank you, Linda. As she mentioned, I'll be talking about the design, that is the front-end design, the back-end design, and the overall design. Talking about the front-end design, the major two components of the front-end design are the Windows application and the web application. It is through this Windows application where the admin or the hospital authorities can upload each of these medical reports. And with the help of the web application, the doctors can view and see these summarized reports. Moving on to the backend design, it is where the actual summarization is happening. We have a model called as BirdSim, and we are giving the input as a medical document to the fine-tuned BirdSim model, and the goal summary and the candidate summaries are generated. Goal summary is a reference summary. That is how a real summary should look like, that we are mentioning it using edge highlight. And the candidate summary is a summary with the summary that is generated by the system. Now moving on to the overall design, we have the Windows application where we give the input, and with the help of the fine-tuned BirdSim model, the summaries are generated and it can be edited and uploaded in the web-based application, and the doctors can view and access these summarized reports with the help of the web-based application. Now it's time for us to evaluate the quality of the summarized report. And the quality of the summarization is just two paradigm in our project. That is, one is the automatic method and the other is the human evaluation. The automatic method is using the RUG scores, where RUG stands for Recall Oriented Understudy for Existing Evaluation. Here, RUG works by comparing the summary produced by the model against the goal reference summary. And in human evaluation, a medical professional like doctor checks the quality of the candidate summary generated, and they also ensure that the training strategy which we have used have led to the improvement in the summary quality. Now Pooja will be talking more about the implementation details.
Thank you so much, Parvati. Now I'll be talking further about the implementation of our project. Specifically, how did we fine-tune BirdSum? We basically came up with two different training approaches A and B, which were essentially technical modifications to the training program and how exactly the structure would be fine-tuned or the parameters would be affected by the training that we were going to do using clinical reports. So we came up with two such different training strategies and trained the entire data set on two model variants, Model A and Model B. And now we wanted to compare their performances, evaluate which was it that final model that we would use in our product. And for this purpose, we use the method of k-fold cross-validation, the standard k-fold cross-validation method. We split the entire data set into 10 folds, each fold containing the entire data set split into mutually exclusive train and test sections. So the model checkpoint, the pre-trained checkpoint would be trained on the trained files of a particular fold. And then this resulting checkpoint would be tested on the test files of that particular fold. Essentially, we were trying to understand the performance of this model when exposed to unseen data. And then we ask the question, which is a model that is performing better? Is it model A or is it model B? So now we had result RUG scores of both model A and model B, and we use the averager program to essentially average all the scores of both models A and B. And then we found out that model A was actually giving the improvement that we were looking for, and model B was subsequently rejected. Moving on, this is the result analysis of model A. This is essentially the fold analysis of model A. Here, the tick mark indicates that our model, model A, has performed better than the pre-trained model. The cross indicates that our model did not perform as well as the pre-trained model. And an equal to sign indicates an equal performance in comparison to the pre-trained model. So very clearly, for a majority of 6 out of 10 folds, and for a majority of the parameters shown here, our model has outperformed the pre-trained model on clinical reports. And this is one of the major reasons why we went with model A. Moving on, this is a screenshot of the averager program that we use to compute the averages of the RUG scores. So on the bottom, you can see the scores that we got before training, that is using the pre-trained model on our domain of clinical reports. And using our model A, after the training strategy that we applied, we have used the scores after training, as you can see above. Clearly, there is an improvement on all 9 RUG parameters. And this shows that we have succeeded in fine-tuning the model for clinical reports, obtaining that improvement in RUG scores for this domain. Moving on, we also wanted to perform some final experiments and verification to ensure that we were exactly going in the direction that we intended to. So we want to make sure that overfitting was not happening. Overfitting being the phenomenon where the model learns specific details or data set specific details like noise, which we do not want it to learn. We want it to function very well in a generic mode. And for this reason, we verified that overfitting was not happening. And we also found out the relationship between various hyperparameters like batch size and number of iterations and rug performance, and verified that there was nothing more that we could do to further improve the performance of this model. Moving on. Now I would like to talk about the human evaluation paradigm, something which I feel sets our project apart. This is where we bring in the doctor's perspective on the improvement in summary quality that we got. So we basically ask the question as to how the doctor would rate the effectiveness or the summary quality that is being obtained. So before training, that is using the pre-trained Birdsum model, the doctor said that 76% of the summaries could be considered as effective. Whereas after training, that is using the model that we finally chose, 83% of the summaries were considered as effective, indicating that improvement that we were looking for. Moving on, I want to talk about what is it, the factors that makes our project very special. Firstly, the model that we have chosen. We chose BERT, which is essentially the current state of the art in the field of NLP with extensive pre-training. And I feel that this foundation has really helped us minimize a lot of effort. And even in future, it will help reduce a lot of effort in further fine-tuning this model for even better applications. Secondly, we have explored and evaluated various strategies and finalized on the very best strategy to be used in our final product. The third point is that we have a comprehensive evaluation strategy. We have evaluated using both an automatic rug metric and a doctor's perspective to completely evaluate the summary quality from all perspectives. And moving on, we have also developed this project in a real-time scenario, in a real collaboration with doctors and IT staff from a local hospital with whom we have collaborated on for this project. This makes our project readily deployable in all medical institutions. And then we also have very user-friendly interfaces for both the admins as well as the doctors. And we also have incorporated various security and privacy features that make our product compliant with various patient privacy preserving agreements like HIPAA and GDPR. Moving on, I would like to talk about the conference that we recently presented this research at, the IEEE International Conference on Emerging Technology. We have recently presented our research work at this conference, and it has also been published in the proceedings of the conference. Our full paper will be published through IEEE Explore within 5 months and will also be indexed by Scopus, as has been informed by the organizers. And finally, I would like to talk about the scope for future work on this project. We believe that a lot more can be still done. We can definitely further train this model on a bigger data set. We can bring in new features like natural language inference and question answering to further augment this model. We can create a heightened understanding of context, a much more advanced human-like understanding of context within this model to better summarize. And finally, where does all this lead to? We feel in fact that we can create an AI-powered medical assistant to support doctors in decision-making, especially in a current scenario like COVID-19, where doctors are really constrained for time. Such an assistant has real relevance, and we believe that our work is a first step towards moving towards that goal. Thank you. That was the end of our presentation, and now Divins will carry on with the demo of our project.
Okay, fine. Thank you, Pooja. So that was the end of our presentation. Now, finally, let's move on to the demo, and I'd like to show you the output of what we've done and our project. So what you see on your screen right now, this is Microsoft Visual Studio. This was our choice of IDE for developing the Windows application, which is the application that will be used by the admin. So I'm going to go ahead and start the application. So this is a lock screen that you see right here. The motive behind developing this lock screen over here, I'll talk about that later in this video. Now I'm just going to go ahead and sign in. So once you're in the application, as you can see, the application is neatly laid out into two different sections. There's two ways in which you can supply input to this program. One is as a text file, and the other is as an image file. Both the options are similar, except that if you select the image file option, it will perform OCR on the selected image and extract the text and display over here. So for the purpose of this demonstration, I'm going to be selecting the text file option. So this particular text file over here contains a lengthy medical report that we received. So as you can see, the contents of that particular text file is listed, is laid down on the left side of the program. This is the entire lengthy report, and as you can see, we formatted it at highlight tags These at highlight tags are nothing but the goal summary that we discussed in the previous section of our presentation. So to generate the summary, all you have to do is press the summarize button, and this particular window will pop up that shows the different processes that are going on behind. What's happening in the background actually is that it is executing the Python script of BERT, which actually generates a summary. So this process is could go on for a while. It take about 30 seconds to complete. So in the meantime, I'd like to introduce the web application to you. So this is a basic interface to our web application. As you can see, we have also implemented the authentication procedure in the web application as well. So I'm just gonna enter the passphrase and login. So once you're logged in, you will be presented with this beautiful dashboard. We gave a lot of thought into designing this layout. We implemented it so that the doctor can easily reach the required summary with no more than 3 clicks. So in this dashboard, the doctor can perform various operations like searching for a patient using their patient's ID, patient's name or the patient's ID. Okay, so once the doctor selects a particular patient, on the right hand side, it will list all the reports that were previously uploaded to that particular patient. And if the doctor wishes to see the entire, what you see right now over here is the summarized report, is the summary of a particular report. And if the doctor is willing to view the entire full report, he can always press this read full button, which will take it to another page that shows the report in its entirety. So let me go back to the Windows application and see where the summarization procedure has reached. As you can see, it says summarization completed. You can close this window to proceed. What you also see over here is it also evaluated the RUC scores of the summary we provided, the report we provided, and it has also printed those over here. So I'm going to go ahead and close this. So now that will open up another window. Now this window displays a side-by-side view of the output, which is summary that was generated. On the left-hand side, you will get the report in a glance. This particular section was implemented by listening to an advice that the doctor and medical professionals from a local hospital gave us. So what it basically shows are certain few key parameters that are vital and that shows concise that gives a concise summary of what the doctor actually expects to see in a report. So those parameters include, as you can see, the date of the test, type of the test, and the organ under concentration, and a few other sentences which might point to any abnormalities that were detected in the report. These abnormalities can include like the presence of a lesion or a cyst or anything like that. Also, finally, a measurement of such a abnormality will also be given if it is there. And on the right hand side, we have a primary output of our project, which is the output of the BERT summarizer. So this is the extractive summary that is generated by a program. This represents the concise and relevant summary, relevant points, which are actually extracted from the input report. Here now you can perform any edits if it is required, and we can go ahead and close this window. Now, as you can see on the right hand side, we have the summarized text over here, and this entire lengthy report was summarized into this particular piece of compact information. Now our program is all set to upload this generated summary into the cloud. For that, all you have to do is press this verify and upload report button, and this particular window will pop up. So what's happening right now is that it's connecting to the database, and it will populate this particular drop down with all the patient IDs available in the database. So if I select a particular patient ID, the rest of the fields will be auto-populated, as you can see. Also, these fields like the report type, the test date, all of this were extracted from the report. As you can see, the report date was 27th July, which was beautifully extracted and displayed over here. Also, I'm supposed to provide a report heading over here. So I'm going to give my MRI scan as the heading. Okay. And below that, you will get a little preview of what the summary is actually going to be. And there is an additional field which is optional that the admin can provide if there is any optional additional comments are available. So once all that is done, you can press this upload report summary button, and it will upload all the information to the cloud, and it will show this information. So as you can see, I uploaded this report to the patient with the name Pavati. So So if I go back to the web interface and check for Parvati, you can see that the report that we just uploaded appears here. And to see the reports in its entirety, I can go ahead and press this read full button, which will take me to this page, which contains a detailed medical report. Now this page contains every single details of the report, like the patient's detail, the report details, which includes all the key parameters that we previously talked about. Also the full medical report over here, followed by the actual output of a program, which is the BERT summary. One little feature that I forgot to mention before was the ability of this program to program this particular key content extraction feature. So the doctor can always press this configure keyword button and add keywords to provide keywords to this program, so that he can fine tune what will appear uh, in the report at a glance section. So that would be an added advantage to a program. Now that's pretty much all the features that I was going to talk about. And now finally I would like to conclude by detailing a few security features that we incorporated in our project. As this is a project that would operate in the medical domain, we completely understand the importance of security. It is very important, as in it handles a lot of patients' personal privacy mattering issue data, and we also needed to implement data security in a program. So this particular PHP My Admin interface shows the database of our project. So if I go ahead and log into our application, our database, and take the reports table, as you can see, all the data that we collected over here is encrypted. Anything, if you take the raw text or summarized text, as you can see, this is plain gibberish. We actually use 256-bit AES encryption algorithm, which is one of the strongest encryption algorithm out there to perform encryption and store this data on our database. So even if a hacker,
you have 3 minutes to go.
Yeah, okay, sir. So even if a hacker is able to gain access to our database, he won't be able to make any malicious use out of it, because all of it is encrypted. Now the second security feature that we implemented was authentication. As you previously saw, both on the Windows application as well as on the web application, the user will be only granted access once he enters the right passphrase, and this passphrase is stored securely on the database, and the verification that we perform is always the server-side encryption, and the passphrase is also stored in SHA, or secured hash algorithm format, so that adds an extra layer of security over it. Now the final security feature was session timeout. The user will be automatically signed out of the application if he spends like 30 minutes in the web application or 15 minutes in the Windows application as inactive. If that happens, he will automatically logged out and will be shown this particular dialog box, which says the session time out and he needs to sign in again to continue using the usage. So that basically sums up our presentation, and that was the output of our program. Thank you so much.
Thanks very much for your presentation. It was a very well delivered presentation and demo. And
Thank
it's
you,
also good to note that this is based on a real requirement from the medical community. That makes it more relevant. Also, it saves a lot of time for the doctors, presumably. I have a couple of questions. The first is what we've been discussing in the previous presentation. You did mention GDPR somewhere on the in your slides. Unfortunately, this approach is not compliant with GDPR. The reason is that the encryption that is being done on this is your encryption. You, as a service provider or startup or company, whatever, is encrypting the patient's data. According to GDPR, the patient has to control access to his or her data, and encryption will be based on the patient's private key, if at all. So that is actually a problem with GDPR. My second comment is, as a doctor, I don't care about what algorithm you use. I don't care about all the parameters, some of which have been mentioned. What I care about is, A, how effective is the summarization? B, are there any possibilities of errors? Now, medical errors can be very expensive legally and financially. I didn't see any mention of any errors in your presentation. So I'd like to know, and also if you were to summarize this project in a non-technical way for a non-computer science person, how would you say one sentence, 20 seconds long? How would you put it? Maybe you should start with the last question first.
Pooja,
Yes, I can go. Yeah. I think, in a nutshell, if I was to convey what exactly our project does, is essentially we have a huge amount of data through which we cannot have a medical professional parsing every sentence. It's a bit tedious because their focus is on doctor-patient interaction, increasing that amount of time. So what we are trying to do here is making that doctor's job a bit easier by trying to get the crux of that report for him. So essentially, that is what I would say our project tries and does. So that is the summary, I would say, in a nutshell. And with regards to the quality of the summary that was being generated, you, sir, asked about any errors that may have crept up. I can share the feedback that we got from the doctor's side, the doctors with whom we were working. So they were of the opinion that together, the at a glance section and the summary, together they actually form a very good combination of what a doctor would essentially be looking for, because those parameters were actually something that they mentioned, they asked specifically for. And it is something, I think, from a very objective assessment, or from a doctor's very objective assessment way of looking at the report, they would be very happy to see that in one go, instead of them having to look through it and discover each of it. So that part definitely is what is contributed by the at a glance section, and in more detail. For example, let's say that there is this particular organ that the doctor wants to know the status of, which is not necessarily an abnormality or an abnormally marked organ, or something which features in the at a glance section. So that information will be conveyed through the textual summary, because it essentially compresses the report. And like, for example, he just wants to know that a particular organ is functioning well. So that sentence is very likely to appear in the detailed summary on the right hand side. So the feedback that we got is that essentially both together convey a very good summary for the doctor to get an overall analysis of the report. However, we still understand that a lot of work can be done further, and they have also given us suggestions. Like, for example, that the system itself be able to extract abnormalities and its context-related sentences. Now, let's say, for example, in an MRI of a brain, we have a few tumors or a few lesions being discussed about. So then the system would be able to extract the abnormality one, its related sentences, that is its measurement, any specific details related to that particular abnormality, then abnormality two, its context and related sentences. So that kind of an ability would definitely.
In the interest of time, will you please wind up your response?
Yeah, that was it actually. Essentially, it would be really good if we could build on that.
The problem with the doctors looking at the report and then kind of making conclusions on the effectiveness is that an error can happen at any point. It doesn't have to be in the particular report that the doctor is looking at while testing. The error is something that can happen on a dynamic basis, on a particular case by case basis. So what I'm basically saying is that, I mean, it's not your approach is good, although it stops short of drawing inferences, as you mentioned. But the testing process has to be probably much more exhaustive, because we don't know when an error is going to appear, and some of these errors can be costly. I'll request my colleagues to raise their questions.
I think I will ask. I have some questions. See, a couple of things. See, when did you start this project? To me, it looked like you claimed BERT to be state of the art, right? So, SOTA. When did you start the project?
Sir, we've been working on this project for about 2 semesters now.
Yeah, as mentioned before, we got the problem statement from the hospital side in September 2019, when we got a chance to meet the doctor. So it was from then we thought, and we had brainstorming sessions about how to implement our project.
Okay, so have you done recent research on what is a SOTA?
Yes, definitely. Our last 2 semesters was basically research and implementation about the project. We 4 of us brought up different models which we could implement, thought of the best model, that is BERT, and then finally thought of how to fine tune it. So that was the entire research procedure that was being.
My question is, what is a SOTA now? Might not be BERT.
Yes,
right?
sir. We completely understand that, because I mean, deep learning is a field which is evolving with every second.
Exactly. So my question
So,
was around that.
yeah.
Also, see, now you have ErnieGen and Prophet Net and all of them, right? And every 3 months you're going to have. have you thought of how you could actually, and just big leap, it is like major change in accuracy and the quality of output that you get, right?
Right.
Have you thought of, because you're doing it for
Right.
probably a hospital, and specifically something that is that requires very serious thought, say, a lot of
Yes,
precaution
sir.
you need to take. Have you also
Right.
thought of how you could, make sure when you
Yes.
built your application, did you bring in this aspect of able to plug in any kind of deep learning model, right? So that's more of a tip there, right? And so why have you used K-fold? And I didn't understand why you used two K-fold, and what was the purpose of it? That you used two K-fold cross-validation twice, right? Model A, model B kind of thing. What was the purpose of it? It was not clear.
Sir, essentially, we were just okay. I think with respect to the first question about the plugging in new models, essentially, I mean, we had this time constraint. We were supposed to develop this over 2 semesters, and for that reason, at that point of time, with the research that we were able to do, we felt that this would be the best choice because the specific factor, I mean, as we mentioned already, BERT has been extensively pre-trained as an NLP model, and BERT sum, which is BERT for summarization, has also been pre-trained on the summarization task. So there was a data set specific for that, CNN Daily Mail, which consists of news reports and their corresponding summaries. So the thing about this model is that it already knew a lot about summarization. So what it lacked, I mean, generic summarization. So what it lacked was that medical standpoint. I mean, the difference between, summarizing a general document and summarizing a clinical report. So
Yeah.
essentially,
It's
that
a
is
domain
the
specific. It's a domain specific
right,
fine
absolutely.
tuning that you did. So, by the way, ErnieGen and ProfitNet are for summarization. It's not.
Right,
Uh,
right.
it's
Sir,
not.
so basically, the reason why we had that model is because I mean within the
I
time
got. I
constraint.
got that. I think it's a very nice choice. There's no doubt about it.
Right.
It is a very
So,
nice choice.
sir,
But again,
what we concluded from our investigations is that I think we now have the approaches that I was talking about, the training approach A and B. We were able to figure out this training approach that offers a very reasonable trade-off between training time and the improvement that we were getting in the RUG scores. So I
no.
believe that this,
What was the difference? I failed to understand
right,
why.
sir. I
What
can
was
I
it
can
K-fold
okay.
cross validation for model one, and what was it second K-fold cross validation for model
Sir,
two?
essentially, if I was to like summarize a BERT sum architecture, how it would look like is we have the BERT layers, we have the inter-sentence transformer layers, and finally a sigmoid layer which ranks the context vectors of each sentence and selects the top ranked sentences into the summary. That's the summary of the architecture. So for model A, what we did is we would let only the parameters of the extractive summarization layers, that is a second section of the model alone, get tuned using the requires underscore grad parameter. We made it in such a way that only those parameters will get tuned or affected by the training that we do. And for model B, we wanted to try out something which usually works in a CV kind of scenario. We wanted to test if it works in an NLP based scenario as well, where only the end of the architecture is modified. So essentially
Okay,
what
we only
happened,
have 2 more minutes left, so I suggest you please summarize and stop
right?
now.
So then the linear and sigmoid layers would get affected. So essentially these were the two approaches. And
Fine.
K-fold cross-validation, we wanted a common,
I got that. I got that. So one last question. You have how big was the how much of a text could you use, because BERT has a certain limitation, and computationally and memory wise, how big an article could you summarize in, and can you kind of throw a little bit light on it? 30 seconds maybe.
Sir, actually, I think for the kind of reports that we were shown from the hospital specifically, and the reports, the data set was actually provided to us by them for clinical reports. For that, even the longest report that we got, which ran into pages, in fact, even that BERT was able to handle well. So that was
What would that be like? 500 words, 5,000 words,
um,
or in MBs, if you could say.
right. I think we've had reports that have run into 4 or 5 pages.
Okay.
Right.
Okay. Yeah. Thank you. That's it from my end.
Right.
Thanks. Other judges, please.
So I have one question regarding the usability of the system you said. Okay, if I am right, I saw some highlight tag in your input reports, right? Is that right?
Yes, sir. Yes.
Okay.
Yes, sir.
So my question is that who is supposed to make that highlight tags?
Right, sir. Sir, okay. Would anyone else like to go, or can I?
Okay, so that's basically we create a goal summary. So what we do is we take the summary and all the essential sentences which we feel should be in the summary. After consulting a doctor, we put them as at highlights, or we give that tag at highlight in front of that sentence. So it basically is given by the user or from the admin side. So that it's basically used for evaluation purpose. So that once when we calculate the RUG scores, we can find out whether our summarizer does a good job or not. So it's basically for evaluation and it's given by us.
Okay,
Sir,
so that is not an essential part of the text input you have.
Yeah, it's basically for evaluation. It's from our side to check whether our tool does a good job or not.
Okay, then without that highlight, so is there any difference in the accuracy of the reports?
No, basically, if imagine you have an input file, it can be directly entered into our say Windows application, and it'll yield you the summary. The only purpose of adding highlights is just to check the accuracy.
Sir, essentially, like
sorry, we don't have time. So, any other questions, Vishnu? You have any question?
Yes, one question. Usually, the performance are evaluated using statistical parameters such as some metrics. And unfortunately, in the summarization case, all the evaluation can be done, or the performance can be evaluated using subjective methods. So, I would like to know what subjective measures are used to evaluate your method. Is it from only based on the doctor's report or doctors?
Sir, actually, I just wanted to mention that with reference to the previous question, like the accuracy, actually in this
sorry, we don't
project.
have time. Please answer this question and wind up immediately because we are running short of time.
Okay, sir, here the subjective measure that we've used mainly is the doctor's opinion, the feedback that we got from the people with whom we were working.
Thank you.
So,
I think we apologize for the shortage of time, but we do have to close now. Thanks very much, and we'll be in touch shortly.
Thank you, sir.
Thank you.
Thank you so much, team. You may leave now. Judges can move to discussion room. Next presentation is at 12:50. Hi, Anantu. Is everyone from your team in?
Few are still to come, ma'am.
Yeah, actually, you can start if you're all in.
Okay. Let's move on to the next team from St. Joseph's College of Engineering and Technology, Palai, Kerala, to present their project on the topic Odukomban.
Okay, so shall I start?
Guys, you have 10 minutes for the presentation and 10 minutes for the demo. Okay, please keep up to the time. You may start now.
Okay. A very good morning, respected judges. The problem statement that we have decided to act upon for the CSI InApp Awards is what I'll be explaining first. So we all know that in a particular route, multiple buses often fly in the same time. That is, they do not maintain a constant distance between the buses. And it often causes a problem for the commuters and as well as for the transportation category. The problem for the commuters is that when they require a bus in a particular route, they often do not get buses on time. And sometimes they have to travel in overcrowded buses. Other than that, sometimes when there are not enough passengers, there will be multiple buses that go in the same direction. This causes a problem for revenue generation for the transportation department. Other than that, there is also a problem for traffic congestion and accidents that is caused due to the mismatch in timing and there not being sufficient distance between the buses. So what we are planning to do is provide a dynamic scheduler, which will be based on the crowd estimated in particular places, in particular bus stops. That information will be collected and we'll be able to give them a dynamic scheduler, which will be useful in order to maintain a scheduled system and provide sufficient buses in areas where they are required. That is what we are planning to do. So basically, this will solve the problem for the commuters and the revenue generation for the transportation department as well. So for that, other than that, we are also trying to, we have also included a QR system that will be able to, like we can book tickets online. Presently, we only are able to book tickets for long route buses, but we can also book tickets for ordinary buses, and these tickets can be scanned using QR codes, and we don't need, that will be a mode for payment in buses. And other than that, for crowd estimation, we can also use cameras and sensors along with the ticketing system to ensure the accurate number of people in a bus in areas. So how we are planning to do is we will be using three main techniques. That is two applications. One application for the passengers, that is the commuters, and another application will be for the drivers or the conductors. And the third thing is a website. This website will be for the operators, that is for the transport officials, and they will be only able to log in and change the details and the schedules of the buses accordingly. We will be explaining further.
As explained to you, this we have website as a solution. The website is intended for the use of KSRTC operators and higher authority officials. This website has multiple features like bus tracking, bus scheduling, employee details, etc. The operators can log in using their KSRTC login IDs and password, which will be unique for all operators. And using this, they can track buses at any time, get their current geolocation, get the schedule of all buses on a particular route on a particular range of time. They can also update bus fares very easily. Next is our app.
Our app contains we have two applications. One is driver conductor application and second one is passenger application. In driver conductor application, when the driver logs in, he gets the route map and also the alerts which are for the avoiding the overlapping of the buses, and also the route for the from the source to destination. And for the conductor, the interface has a QR code scanner to verify the ticket of the passenger, which will be explained in the passenger application, and also reporting the emergency alerts, and also view the passenger list which are traveling in the bus. Okay. And for the in the passenger application, there are mainly 4 modules. First one is the maps. In the maps, when the passenger or the traveler who wants to travel can track the buses nearby on in real time. Then in the second is timing. In timing, we can get the current schedule assigned by the KSRTC from source to destination of any particular route. Third is bus tracking. Every bus has a triple code number, a unique triple code number, and that can be used to track a particular bus. This is for tracking your loved ones, or for the small children who are traveling alone in the bus, so that we can pick them up, or we can know their live location. And fourth one is the ticket booking. uh, uh, you might notice that currently there are ticket booking facilities, but they are for the reserved buses, which has reserved uh, ticketing. But our booking we are proposing is that we are our system is used to book ticket for unreserved buses also. Next.
For the crowd estimation, to get the details regarding how many people are traveling in the bus, we could use this booking information, the ticket that is booked using the mobile app by the passengers. And also we know that in buses there is this ticketing machine which is used for making transaction with the conductor directly by the passengers. We can install a Bluetooth chip that can cache these transactions and send the details to the app, and this online booked ticket details and the transactions that is processed using the ticketing machine can be combined to obtain the total number of tickets that have been booked for a particular bus in a route. And this information is combined and sent to the server, whether where the crowd information is processed, and then the suitable like indications can be given to the buses, whether how much like they should whether they should speed up or maintain the speed or slow down. And also it is used for the rerouting procedure. And as a future scope, we can also include camera arrays in the buses. Like there is two options for this. One is using a 360-degree camera. Could you go to the next slide? Okay, one is a 360-degree camera, using which we can use the density estimation algorithm, and we can get the approximate density of the passengers that are currently traveling in the bus. Another is using a two-array camera system at each of the entry-exit points in the buses, so that we can mark and get the number of people who are entering or leaving bus, so that we can get a estimated number of people who are traveling at the moment. This is the way in which you can use the cameras to get a accurate, almost accurate result on the crowd.
Okay, now we have the dynamic schedule module of our project. In this part, when you might have noticed that
We have 2 minutes more for the presentation.
Yeah, sure. Okay. We have noticed that there are many buses going on when the passengers don't need it, and there are less number of buses when passenger needs them at a particular location. So our dynamic scheduler is an automated scheduler which uses real-time analytics, data analytics, and also machine learning algorithms to schedule buses where according to the peak times at a particular for a particular route. We'll show more in the demo. Next, the technology stack. For the backend we are using Google's Firestore and Firebase, and for the Maps API we are using Google Map API. For frontend we are using Flutter's framework, and for the data, the camera, we are using OpenCV, and for data analytics part we are using RStudio, and for the algorithm we are using the card decision tree classification algorithm.
Okay, as a future scope of this application, as already mentioned earlier, we can add sensors and cameras to accurately predict the number of people inside the buses. That is a future scope. Other than that, we can also add rewarding systems. Since all these buses already have a GPS tracker, we are able to understand the speed in which these buses will be traveling. So according to that, we can find the people who are not following the rules and award the people who are following the rules. So this is also a future scope in this application.
Social relevances. Our app will make bus travel more convenient for people because
Time is up. So will you summarize in 30 seconds, please?
yeah, sure. It will help many people make their travels much more convenient, safer, and since the rules will be abided to by the drivers and conductors, it will also help prevent accidents in future and also will result in increase in revenue generation.
Now I will show you the demo. Anandu.
Okay, so this is how the Visual Studio, the source code that we use to create the app. They use Flutter for this because it's open source and it is like on the rise. The hype for the languages. It has nice support and development going on right now, and like when the user logs in, opens the app, they are greeted with the login screen. They can log in with their credentials and open the app. And this is a passenger side of the app. Like there are two different apps, but for simplicity, like we have combined both. The conductor app is also available here in a drawer, and so is the driver part of it. The conductor driver app is the same, but for convenience, we have made it into separate modules. So in the map section, we can enter the tour from location and find the duration and distance and duration of travel. Like for example, here from Kochi to Pala, we are making the search here. You get the distance 66.6 kilometer, 1 hour 50 minutes for travel, and the route. We can a future scope update for this is we can also provide the nearest bus stop, like the bus stop and the timing of the bus to get from this Kochi to Pala. That can be added in the future. Then next.
Also in that we will be showing the buses nearby the user, so that also it will be displaying it in a color code. For our red color will be shown so that the bus is filled, yellow partially filled, and the green for it has space. So
And
continue.
next module in passenger app is the timing. Here the same procedure to and from information, and we also enter the bus type, super fast or any ordinary, and then the time of day when we want to travel. Currently, we do not have access to the entire schedule of the any bus department, so we are using Anavandi website to like fetch the details of the travel. And next is the tracking. As mentioned before, we can enter the bus fleet number, triple code, and get the live location so that we can track it. And since we do not have the like coordinates, real-time coordinates of any object that is in route, we have no practical way of showing this. This can be implemented using the Google tracking API. So that's a possibility. And then the booking. The passengers can book the tickets from between two locations. They are displayed all the information regarding the travel, like the cost of the ticket and so on. And they can also proceed to payment and make the payment online. Now we also have the help section and my booking session. After the booking is made, all the book tickets will be shown here. And in the help, you can send any report. If there is any issue that occurred during the commute, you can send that report here, and it will be sent to the depot or the bus department. And here the helpline numbers will be shown, and the facts regarding all the different modules in the particular app is also displayed. Next is the conductor app. Here we have 4 modules: a QR scan, Bluetooth, emergency, passenger. The QR scan is still under development, but using this, the conductor can scan the tickets that is booked online, and the tickets can be issued to them. Then the Bluetooth is for pairing with the ticketing machine, which I mentioned before, in which a Bluetooth receiver is kept, so that the transaction details from the ticketing machine can be sent to the app, so that we can get the entire information regarding the tickets that have been booked. Next is the emergency, which is same as the help section in the passenger app. You can send reports, and all the information regarding the conductor app is shown here. And then the list of passengers can be shown here in the passengers list. You can get a number of passengers that are currently traveling in the bus. And finally, we come to the driver app. The driver app is only for showing the driver the current location and whether they are on time or not. It is indicated to them whether they are, I mean, in the route that they're supposed to travel, whether they're overlapping another bus or not. If they come too close to each other, as I'll show now, sorry. And then the indication is changed to yellow, and if they become too even closer, then they're overlapping, essentially overlapping each other's route. So that is a red indicator for them.
So this alert will provide the driver, will be given to the driver, and the driver will be able to understand that the buses are nearby and will be able to maintain the speed accordingly. So this is actually how we'll be able to avoid the problem of overlapping of buses.
As a future improvement, we can also show the recommended speed the driver is supposed to travel, because just a simple indication of whether they are overlapping or not may not be sufficient to allow them to maintain a perfect schedule. So we can also show the recommended speed by making more analytic and more processing.
Also, it will be the delay and the traffic ahead will be considered. So for the recommendation speed.
So, is there anything else?
Yeah.
The website.
Yes, the website.
Okay. Thanks very much for your presentation.
Yeah, we have more.
We have a website.
Oh, your website. Okay, do it fast.
And also we have this this algorithm that we generated using RStudio. All the research has been done on in the RStudio using R programming.
You have actually overshot your time because there was 10 minutes for the presentation, but okay, go ahead.
Sir, this is a website. This website is intended for the use of KSRTC operators and officials, as told you before. This has many facilities, one of which is bus tracking. Using this bus tracking facility, the operators can enter the unique triple code number, unique for each bus, and enter the starting and destination locations. And they will, using this, they will be able to track the bus, get the real-time location of the bus. Next is employee details. In employee details, the operators can get the personal details of a particular employee by entering their personal details such as name, employee number, etc. And then they also have conductor and driver list. This is a list of all the conductors and drivers currently on duty. This website is linked to our driver conductor app, so they will directly get the names and details of all the drivers and conductors on duty. Next is bus schedule. This will provide a schedule of all buses available on a particular route in a particular range of time. Next is bus fare. As we know, bus fare keeps updating regularly. So using this website, the operators can enter the minimum price and price per kilometer, and the bus fare will be automatically updated on our app's website and the conductor's ticket checking machine.
And to show the algorithm.
And this is the we used RStudio to work on the algorithm. I'll just show you the PDF format of it. So there is a basic variables like the speed variable, the distance between the previous bus and the current bus, the next bus and the current bus, the crowd in current bus and the crowd in next bus, and so on. And using this, like, we have generated a simple algorithm based on whether they are like distance is maintained. We have made a table, a variable which indicates whether they should maintain speed, which is 0, 1 for slowdown, and 2 for increasing the speed. Like we use the cart algorithm, which is a decision tree algorithm, for making the decision based on the current details. We use the data analytics previous like over a time we will like see that data that is available to us, and we will keep on updating this the model to better to have better accuracy for suggesting the like the recommended indication. You can also use the speed and time parameters for better accuracy. That is a bus scheduling for the maintaining whether they are overlapping or not, whether the two buses are overlapping and maintaining the distance.
Hey, now your time is up. So
We'll round up in just 10 seconds. Yeah, just show you the rerouting.
Rerouting part. Like in every area, there are several routes, and each route there is a bus. So if we were to take a bus and reroute it to a different route, which requires more buses because of overcrowding or due to a peak time, then we can do that. Like this is a peak time analysis for a particular route. We can see that there is peak time during like 9 p.m. and 4 p.m. 9 a.m. and 4 p.m. Like, similarly, we have the analysis for different routes, and based on that, we can select which route we should like schedule the buses. Rerouting can be done. Like in this case,
please wind up now. Your time's up.
Yes, sir. Let's finish.
No more extensions, please.
Okay, sir.
So we are. I think it will be good if you had planned your presentation to stop 1 minute before the allotted time. Then you would have been perfectly on time.
Yeah.
You seem to have a lot of things to tell us. So it's an interesting project, and if successful, it is a like an impactful project because everybody can use it. But I have a question for you. In 10 seconds, can you tell us what is the central problem you're trying to address?
The first problem.
The central problem.
Central problem is the overlapping of buses and also the scheduling when the holidays
Have
and
also. So if you take overlapping of buses as a central problem, have you completely resolved the problem?
yes.
Are you sure?
Yeah, 90%, because we can't be 100% on this, because
so if you have a central problem, the normal approach would be to completely resolve it, and then if you have further time, take on additional things. But you seem to have taken a number of things on, some of them unrelated. For example, the information on data, I mean the driver's salary, it is against all personal privacy laws of the country. It's illegal actually.
No, sir, we are not providing the data.
We saw the information as a PDF file with the gross salary in one of the columns.
Yeah, that was provided on the KSRTC website.
No, but that is KSRTC's internal thing. We don't have to take it up and show it, because the central problem is overlapping of buses.
Yeah,
So
actually,
the
salary, it wasn't the salary we meant. Right there, we just wanted to like demonstrate the list of currently.
But see, taking a piece of information from someone else's site, you have done it at least twice. One is this one, other is the that other website for the schedules.
Yeah,
that is not a innovation. You are actually reusing somebody's work.
Because we started this project in the lockdown, and we submitted it in the transportation department, and we have requested the access for the website, the data schedules for the buses. But during the lockdown,
See, the point is, if someone else is already providing that information, why should you also provide it? Yeah, people can go to that site and take it, no?
Yeah, but if everything is at one place, that would be more convenient, right?
But then you are entirely dependent on that person. Suppose that person prevents access, then you are stuck. So
currently we don't. So basically, the website is actually contains all the confidential details of the employees of KSRTC only, and it is only being used by the transport officials. The lay people or the commuter passengers, no one else is.
The point is, the laws of the land are very clear on this. You have no right to access the data. You as an enterprise or a startup running this operation have no right. You're not KSRTC staff. You've not been so basically there is no way you can use this data. Okay, I will stop here. I will ask my colleagues to ask questions.
Okay. I will get into a little bit. I think I have a very similar opinion as Satish had, right? But just to get into, you used R Studio. Basically, you used R. R Studio is just an IDE, right? And what did you use it for, right? To generate the PDF,
No,
or
for generating like an algorithm that can be used to suggest like based on past data and
so that
like
it comes to the question where you use decision tree, right? You use R part,
yes.
for example, right? In R, and what is that you're actually classifying? I saw that in the code you had, R part, and you are doing certain classification with the decision tree. What is the final classes? What are the classes in your training data set? What are you
Like
trying to predict?
whether to speed up, whether the bus should speed up or slow down or the maintain the speed. The driver is indicated this
So three
in the
classes,
app. Yes,
three
sir.
class. Okay. So, but from where did you get the uh, training data for these three?
I generated the train data by myself. That it was a dummy data that
Sorry,
doesn't
sorry to
generate.
interrupt, but you use R norm to generate random numbers as data,
Yes.
right?
Yes, sir.
That is actually a very funny approach, that you generate your own data for classification. What is the use of
Training.
that classification that you?
Exactly.
Like when the data was generated, we made sure that like it was like using like parameters. We made sure it is having this particular value like between those values, so that we can get like proper instead of like really big numbers. So I don't understand like what did
So
you?
if you generated data, let's
Yes.
say you generated random numbers, or you use some rules to create the data set, it doesn't make any sense to actually use a machine learning algorithm there to because that's not the real. Your model is not. It just works on that particular data set, right? In real world, the situation is very very complex, right? And the real world data is very different from what you have generated. That's the point.
So we didn't have access to the real world data, so that's a like I decided to generate the dummy values.
Okay.
And also in the case of bus scheduling, like we didn't have the access from the department. All the bus schedule, like we sent an email asking them, but there was no one to answer due to the COVID crisis. So like we didn't get any reply from them. So that's why we decided to use fetch the information from a different website.
Just to show you the demonstration, that's was
It's
the only
only part of
purpose.
the demonstration,
Got it.
we
Okay.
haven't copied the information.
That's okay. So, what are you doing on the rerouting thing? Are you using any optimization algorithm? What exactly? Again, you talked about that in a R programming language context, right? So, what did you do on the rerouting?
So we'll use the past data like for 1 year, 2 year maybe, and we'll analyze all the peak time, like whenever the during
I
different
got that. So
seasons and
we saw that you had a chart with the three differing peaks, right? Like three different peaks.
for 3 different routes.
Different routes, right? So
Yes, sir.
why did you use R for it? Right? You could have used any other whatever
So for in
programming.
R, we can easily make research purpose and all. R is preferred for like implementing the app inside an app. Use Python. That's what I learned. So like for ease of like presentation, I
If it is
decided
just
on using
peak
R.
basic math, everything you can do in any other language, right? Whatever you
Yes, sir,
use.
we can.
Okay. Okay. So I think I just have this. I just had these questions, right? And if you are given the second chance again to tell what is the most innovative thing in this, Satish sir already asked that, right? But what is the most innovative thing you really want to rethink and tell? 30 seconds. What is the most innovative thing that you've worked on in this
Um,
project?
Most innovating thing is the scheduling. The
Okay.
because
Got that. Thank you.
yeah.
So I think I'll
So
pass
thanks
on.
for that. Other judges, please.
No, I don't have any questions.
Vishnu.
Nothing, sir. Nothing.
So thanks very much. I think you have taken on a very fairly complex project. So it's a very valiant approach, and I think you have worked very hard at it. There are some practical problems in taking up this sort of a project, especially that working with KSRTC is not at all easy.
I know.
You're going to be having a lot of trouble in getting information from them, and even to maintain that consistency of information, they might change it later and so on.
Yes.
And the challenges of lockdown, because there's nobody in KSRTC to even help you out with these things.
Yes.
So we understand all these challenges.
Hmm.
So congratulations for your work, and we will get back to you. Thank you.
Thank you so much.
Yes, sir.
Thank you, sir.
Thank you, team. You may leave now. Judges can move to the discussion room. The next presentation is at 1:30. Hi, is everybody in from your team? Yeah, mute. Hi, is everybody in from your team? Just a second. All good things have to come to an end. It's time for the last presentation of the finals. It is on the project AI Birdie by the team from the college, Sarvajani College of Engineering and Technology, Surat, Gujarat. All the best team, go ahead.
You have 10 minutes for your presentation, 10 minutes for a demo. Please mute. All of you must mute, except the one person. Please go ahead.
Yeah. So, good afternoon, one and all present today with us. First of all, I would like to thanks the judges for giving us this opportunity. It's an absolute honor and a privilege to be a part of this competition. So the name of our project is AI Birdie, and we, the students of Sarvajani College of Engineering Technology, are going to present. So AI Birdie, leveraging the power of AI to democratize ornithology. Here are the team details. And this is the complete outline of our presentation for today. Coming to the motivation, so what motivated us for this project? Birds are an important indicator of the overall health of the ecosystem. And there was an analysis done by the IUCN Red List, that is the International Union for Conservation of Nature. And it showed that there is a steep deterioration in the number of bird species around the world. And highly threatened species continue to go extinct, and there is a complete sharp decline. And at least 40% of bird species worldwide have declining population. So this is quite alarming, and it is up to us to take care and preserve our biodiversity. So diversity in India makes this task very challenging for us to create an automated system. It is very difficult to acquire enough data and find many trained bird watchers that can help in validating the observations. And manual methods are just not scalable to process large amount of audio and visual data. So if we can create tools that can help public to learn more about their environment, people might regain a strong attachment to nature and thus be more open to protecting it. Public participation is vital for some of the most crucial projects like long-term bird counts to assess changes in ecosystems and habitats. And there is currently no one application in the Indian market which is focused to the Indian subcontinent and which serves to bridge this gap. So this is the problem definition. So in a country like India, where there is a vast richness and abundance of bird species in diverse habitats, it is practically very difficult to acquire enough data, and it is quite challenging to design a system which can help us identify the species and help in aid in democratizing ornithology. So there is this gap that needs to be filled between ornithology and the people. And this is the solution that we are proposing. We propose to develop a system for automated multimodal identification of bird species from both visual and acoustic data. We strongly believe that such a system would greatly improve the efficiency and the effectiveness of the bird community and the bird monitoring process. So our goal is to create a one-stop application for all the bird watchers and wildlife enthusiasts out there in India. And leveraging the power of AI, it will have features like bird detection from acoustic and visual data, trivia, and a personal dashboard service as well. And our product is completely different in use case to the well-known bird database portals like eBird, where the search or retrieval is only through names and keywords. So our application is completely automated multimodal identification. So this is the implementation flow of our project. As you can see, the product has both the audio and image classification modules, and the corresponding processing will take place. And our product works both online as well as offline. So user has the option to do the classification on cloud, online, or on device as well. And the result along with the trivia will be sent as an output to the user. So this is the technologies which we use. For front end, we have used Flutter. In the back end, we have used Efficient, both an on device and a lighter. So we have used a lighter version on device and the complete model on cloud. WaveGAN, TensorFlow serving, and Google Cloud Platform. So here are our project modules. So we have 5 modules. the visual classification module, the acoustic module, the dashboard service, trivia module, and the veterinary services module as well. Coming to the first important module of our project, the image classification module. So before starting, I'll just let you know what are some challenges in bird classification. Category level recognition of object depends on the discrimination of the overall structure. So it is say very easy to train a model to differentiate between a cat or a dog, or say a table and a chair. But a project like this requires fine-grained classification. So as we increase the number of classes of interest, classes become more fine-grained and it is extremely difficult for segmenting and for distinguishing the same. So previously we had used the Caltech UCSD bird dataset. And since the second round, we have come up with our own dataset, that is the Common Indian Bird dataset. So in the Common Indian Bird dataset, we have a common list of bird species available in India. So any user anywhere will be able to use our application. So this increases the overall scope of our application. So what's new has happened since the second round. So we have created our own dataset, that is the Common Indian Bird dataset. We have implemented the EfficientNet algorithm on cloud. There is a complete change in the overall accuracy of our model. And we have also implemented the offline visual classification of model as well. So for that purpose, we have used a lighter version of EfficientNet model. So these are some state-of-the-art models, and you can see the results. So previously we had used the Inception ResNet model, but currently we are using the EfficientNet model. You can see a sharp decrease in the number of parameters, say from 57 million to 19 million. And on the Caltech, we had achieved an accuracy of 92% on the top 5 results. And after augmenting the data set with our Common Indian Bird data set, as you can see in the last row, we have achieved an accuracy close to 91%. So now coming to the acoustic classification model. So previously we had trained our model on the GNHP dataset, that is the Greater Northern Himachal Pradesh dataset. And now we have, as like image, we have created our own database to increase the scope of our application, that is the Common Indian Bird dataset. So total for audio now we have 56 pieces. So what's new has happened since the second round. We have collected our own dataset, that is the Common Indian Bird dataset. And there is an improvement in the overall accuracy of our model after augmenting the dataset with the existing dataset that we had. Now in the acoustic classification module, we have two sub-modules. The first is the bird activity detector. So we have designed a bird activity detector based on the logarithm of frame energy, which will identify the part where the bird call is present. And then that part will be extracted and then it will be converted to MFCC. So MFCC stands for male frequency septal coefficients. So now the MFCC features will be taken from the clean bird calls and a context embedding of 15 frames will happen. Now this part will be fed to the input layer. And we have 5 hidden layers in our deep neural network. And the output layer is 56, as currently we have 56 species. So in this way we are training, and this is the visual representation, layer-wise representation of the neural network. And there are some issues that we had faced. As the data set is small, it resulted into audio imbalance issue, eventually leading to imbalance classification and overfitting. So to address these challenges, we have used some of the methods. Say we have used L2 regularization and dropouts. And to address the audio imbalance issue, we took a novel approach in the form of waveguide, which will be explained by me in the later slides. So first, I would like to share the results that we have got. That we got an accuracy of close to 84% on the top results on the GNHP dataset. Now, after augmenting the dataset with our own dataset, that is the Common Indian Bird dataset, we are currently getting a top 3 accuracy of close to 88%. So now this is a very interesting part of our application. So to address the audio imbalance issue that I had mentioned earlier, so we took a novel approach in the form of audio GANs. So we have used the waveGAN model in this. So waveGAN is basically the first application of GANs to unsupervised audio generation. GAN stands for Generative Adversarial Networks and is generally used to augment images. But in this application, we have used waveGAN to synthesize raw waveform audio by observing many examples of the real audio. And waveGAN is based on the popular DC GAN approach. So right now, I'll be sharing some of the results from our research that we have got. So this, tell me if you are not able to hear it. So this is the original grade barbell. I hope it was audible to you. Now this is what we had generated from the waveGAN model. So as you can see, the waveGAN model was able to retain the characteristics from the actual bird calls. And just to quantify these results, to give a matrix associated with the quality of the output, we took two of the models, and for training we used the synthesized bird call that we had, and for testing we used the actual data set. And we are achieving an accuracy of close to 92%, which gives you an idea regarding the quality of the synthesized bird calls. And this is just a very small sneak peek of our research we are doing, as we have currently not published our complete research, and we have also done 3 to 4 more cases. So after we are published, the viewers will be able to see our complete research. So this is the complete user interface of our application. You can see on the screen, you can see the trivia screen, the audio results that the user will be getting, the complete veterinary services module that we have. And now in the complete demonstration, we'll be going through all of them. So now coming to the future scope of our application. So the future scope is, gets all of us so excited, as there is so much to look forward to. waveGAN has been successful in generating large amount of data and can be used in the backend to augment a data set. The application can be scaled to make it more robust and inclusive, with an increase in the availability of data set and the crowdsourcing module. And based on some of our research on the UI UX, the application is more appealing and it is theme centric. So we have moved forward in creating a very seamless UI for all our users. The same models can be used to develop IoT products and hands-free devices, as well as on virtual assistants like Alexa and Google Assistant. And ending a presentation on a very positive note, the application has been developed with an aim to involve the local community and to garner awareness regarding birds and its conservation. And the proposed system, if deployed on a large scale, can be an effective tool for continuous bird monitoring and can be of immense use to all the ornithologists, farmers, governments, and any enthusiastic bird watcher out there in India. So we thank you for patiently listening to our complete presentation. And now we are moving on to the demonstration part of our application. So I would now request my colleague Jamie to kindly share his screen for the demonstration. So welcome to the AI Buddy application. So as you can see, as soon as the user clicks the AI Buddy app icon, he or she will be able to first able to access the screen. So if the bird is present in front of him, he can quickly capture the image and get the results. On the right, we have a similar UI for audio recording. Now first I would like to go through the dashboard part of the application. On the dashboard, the user has a complete overview of the different images he has captured till now and the different audio clips he has recorded. In the image tab, he'll be able to see the complete history of all the images he has captured till now. And in the audio tab, he'll be able to see the complete history of all the audio bird clips that the user has captured till now. So first, before starting the app, the user will have to sign in into the application. As you can see on the screen, the sign-in is now successful. First, I would like to take you to the veterinary services module. So we have given a lot of thought into this project. So we wanted to integrate this feature into our application. So if the user sees a bird that is injured, he can quickly call onto the nearest helpline and get the bird the healthcare that it needs. And the next step will give you a complete list of all the supported species we have till now. So the user has an idea of what the application is capable of currently. So now I would like to take you to the checklist and the notes section. The notes section helps the user add any notes that he wants to. Like if the user is say going on a track, he can add any notes, say where the bird was captured, in what location, or any other notes he wants to add. And in the checklist section, he will be able to delete the same as well. And in the checklist section, the user can have a complete checklist of the different images, if the different birds he wants to spot on that particular day. So he can have a complete list. This feature we also have in our application. So now coming to the most interesting part of our application, which you all have been waiting for, the image classification module. So as soon as the user will click any of the bird species, so in this case, as you can see, the our colleague is using the blue jay species. So now he'll click on the identify button. So as you can see on the top, the user will be able to see what image he has captured. So what is happening is the image that we have right now is being sent to our model hosted on the cloud, that is the efficient model, and we are currently achieving an accuracy of close to 91% for the same. So what will happen is as soon as the output will be displayed, so as you can see the model has correctly identified that is the blue jay species, the user can scroll down as well. So why do we have this feature? So I would request my colleague to click on the first bird image. So as you can see, the user will be able to see a complete trivia of the application. And he will be able to see the similar images as well. So he can compare what he has seen and what the actual bird looks like. Now coming, so the user has option to do it both online. He can upload an existing clip or image as well from the internal storage. So for this demonstration, I would like you to show the audio clip. So we'll be uploading an existing audio clip that we have in our internal storage. And the user will be able to listen to the clip as well. So as soon as the user hits the identify button, similar to the image classification module, the clip that the user has recorded will be sent to our model hosted on the cloud, and the result will be displayed here. So this is a very big project that we had on our hands. Starting with, we didn't just want to do so there is no one application in India right now which is catered to the Indian bird species. But we have been able to manage both the image classification module and the audio classification module. As you can see, the model has correctly identified the bird species. So, and the user can do the complete same classification offline as well. So this is a complete demonstration of our application. Hope you enjoyed it. Now the room is open for Q&A.
Thank you very much. That was certainly a very interesting presentation. So I have some comments. Some 8 years back, we had done a project here, which was basically looking at the biodiversity changes over a long period of time in the Western Ghats, which is the mountains. Yeah. And the device that we used for that was an Arduino-based microphone with a solar charger and a GPRS shield that would be placed in the forest to record birdsong. And from the data, because we wanted both qualitative and quantitative information, how this is changing over a period of time. So it is supposed to be there for about 5 years in place. So so this is in the Western Ghat Hills. And currently there is a project on the same NGO, which is trying to identify individual elephants by name from long distance shots. So this is interesting for me because I've been working on this some time back. But I see that your birdsong capture is using your mobile phone, and that is not going to work at all because a mobile phone is not the right kind of device. You need an specialized microphone, all-weather microphone that can be used outdoors if you're really seriously into this. So even a picture with a mobile phone is okay, marginal kind of utility. You really need, because you're not going to be standing next to the bird. The bird is going to be somewhere else. You're going to see only one part of the bird. We have the same problem in identifying elephants. And apparently it turns out that for identifying an individual elephant, the ear is the best part. So if you can get a picture of the ear, we can identify the elephant. So that work is still going on. So the other comment that I have is regarding the use of GAN. I'm a little bit nervous about generating a lot of data based on very flimsy, a small amount of data. So you're basically perhaps working out the permutation combinations from that little piece of data and magnifying it, and then using it to kind of train the network. So I understand the value of GANs, but I'm a little bit nervous about using in this kind of situations where the actual data, real data, is very little in size. So those are my comments. Do you have any responses?
Yes, sir. And I will like to add if any of my colleagues want to jump in as well. So coming to the first question, actually our main goal is to democratize ornithology. As we had mentioned, some of the projects that you are using it, but if a general user anywhere wants to use our application, so our primary goal was to democratize ornithology for each and every person in India. So he has access to the complete trivia, and that can some garner some sort of awareness in all the uh, students and people out there. And coming to the GAN part of our application, so this is pretty much a research part that we're doing right now, and we had got some very interesting results as well. So as I think as soon as we publish the same, we'll be very happy to share it with you.
So I can also add something to what Vishal has said. Can you hear me?
Yes.
Hello, sir. So thanks for those comments. They actually are quite relevant and quite useful for us also. So I'm a faculty and their advisor. I'm a faculty at IIT Mandi, and this is a part of a bigger project. And in fact, we are. This is sort of encouraged by the Himachal Forest Department. And so on. So I mean, this whole thing started, with some discussions with them and so on, right? So to answer your first question, I completely agree that the sound is actually, it's very difficult to be recorded using mobile phones. Now, what we've, what I mean, of course, the system is of course open for feeding in sounds from a recorder. In fact, in the bigger project that we are currently doing, we are in fact getting more professional, recorders, like more, the bioacoustics recorders like SM4 bioacoustic recorder and so on, or the Swift bioacoustic recorder. But so there is an option of course, feeding in audio with that also. But as Vishal essentially said, is that because we are also targeting a citizen science application, the limitation that the poor quality sound that may come in with the mobile phone, that may be offset, that may be offset by the option that we are not, the sound classification module is not giving you a single option. For example, just like in the image classification module, the sound classification module will also give you a bunch of options. Now your actual correct bird, because of the background noise or because of low quality, may not be the top one in that list, but based on our results, we are seeing that the actual correct bird is, say that when we compute the top 5 accuracy or the top 10 accuracy, it is very likely that the actual correct bird is included in the top 5 or the top 10 list. So now when a user gets that list and he can play each sound and then manually identify in that top 5 or top 10 list which bird sound is closest to the what he actually heard. So in that sense, the low quality of capture through the mobile phone is is partially at least offset by providing these multiple options, right? With regards to your second question, and of course you can suggest, you can make further comments on this also. With regards to your second question about GANs, so yeah, so the GAN, I of course this is a very new area, and we've got results for a handful of birds right now. But the idea behind this is that for some birds, we have a good amount of data for the more common birds, or the birds which at least more sing more commonly. For the other birds which are for which we don't have so much data, so suppose we have only 30 seconds data and so on and so on. So if you want to improve the accuracy, so the GAN is only targeted for those birds. We are not attempting to have a a very general GAN which can generate sounds of all birds. But say out of say 30 birds or 40 birds which the app can handle, suppose maybe 5 to 10 birds are we have less data, and because of which the classification accuracy is dropping down. Only for such cases we are using we are actually taking the help of GAN to generate more data. For the birds which have enough data, we don't have any such issues for getting a would at least a reasonable top 5, top 10 accuracy. So in that sense, the use of GAN is very limited, because I agree that we shouldn't trust at least in an app which people use. We shouldn't overly trust these GAN based models. But that's why we are aware of that, and we are actually keeping the use limited to the cases where we really need more data. And incidentally, as Vishal showed, gave an example, the GAN results are actually quite interesting. So we are in
we
fact
see that. But in view of time, I would like to request my colleagues to ask their questions now.
Yeah, so one quick question around the GAN itself, right? So the purpose, there are easier methods, right? So what you're trying to do is to take a data set, so you have class imbalance problem, and the classes that have very few samples, you're trying to region. But then that can be solved with very traditional methods like bootstrapping, like SMART, right? Which takes care of it. And actually, we are adding complexity by bringing in complexity in terms of computation, in terms of, you're not sure of your GAN model first thing, what comes out of it, right? And so there, it's a generative model, right? So you're basically, pulling information from what is already existing. And that the better thing would be actually to go and do bootstrapping or SMART or anything like that, just to, and I find it very, not necessarily the right way of augmenting the data in this particular case, just because if it was just to take care of class imbalance. So
sure, we can compare bootstrapping, but our motivation of GAN is simply, of course, we have not tried bootstrapping for this application, but our motivation of GAN is that in other applications that I work in say medical image applications or other applications, we have.
No offense, but can we have the students respond to these questions?
Oh, sorry. So we've actually seen that GAN actually performs better than bootstrapping. This is coming from other application, but we have not tried it in this application.
Yeah, but I think it's a nice initiative.
But we welcome your suggestion. Yes.
Yeah, it's a great initiative. But have
Vishal, you're not audible.
Yes, sir. So just to add on to what Anas has said, so basically under guidance of both our faculty guides, just we are doing, so this is a different, very small part of research module. So we wanted to just share this. So the major part is the image classification and the audio class, the complete app that we have built.
Okay. So have you explored the AI experiments by Google and what the Cornell Labs of Ornithology has been doing? And were you able to learn from something there and adopt it?
Yes, sir. So we have compared our results with the work that Cornell is doing as well. So we had a different model in this. So we have not achieved an accuracy up to the par that the Cornells have achieved, but we have achieved a fairly good accuracy. And so we wanted to cater this application just to the Indian subcontinent. So that was our prime motivation behind it.
Fantastic. Yeah, I don't have any other question. I have a PhD actually that involved biodiversity.
Great, sir. So we welcome all your comments. Actually,
so it's nice work. I really like this kind of effort. Good. Thanks. Keep continuing.
Thanks, Brajesh. Now over to Nilakandan and Vishnu.
I don't have any questions.
So it's a great job. I do have a question. Is there any improvement measures in this existing result?
Existing measure as in?
Actually, it's a great job done by your team, and still we can improve the result, right? So is there any idea to increase the improvement?
Yes, sir. So we are using the following methods that are being used, such as the regularization and dropouts, and so on and so forth. So basically, the new data set which I had generated was post the second round. So we are still figuring out different methods to sort of increase the overall accuracy. So the prime motivation behind designing this data set was we wanted to curate a list of common species available in India. So each and everyone will be able to use the same, just not in a forest setting.
Okay.
We can also mention that we have used EfficientNet, which is a model which was actually the paper came out in 2019. And we have used that deep learning model for the image classification, and it is giving us very good results. So this development is also after the second round of CSI. Yeah.
So I think the improvement is needed in audio classification.
Yes,
Apart
sir.
from, yeah.
Yes, sir.
Right. So thanks very much for your work. It is excellent and subject close to our heart. So keep the work ahead, and we'll be tracking your progress and see where you go. Congratulations and best of luck. And thank you for participating.
Thank you, sir. Thank you, sir. It was a privilege to be here. Thank you.
Thank you.
Thank you so much, team. You may leave now. This presentation marks the end of the final round of presentations. This year's projects were a wonderful mix of technology and domains ranging from facial expression synthesis to self-driving vehicles. I'm sure that these sessions have excited anyone from the tech domain. We hope these projects have inspired numerous among you to dive into such exciting domains and projects. With this, we have reached the end of the final round evaluation schedule. I would like to extend our sincere thanks to the judges for taking a big chunk of their busy schedule to help us evaluate this project. It would be really wonderful if the judges could share any of your valuable comments on the final round projects, or maybe something about the image in general. Please.
I'd rather not, because I'd like the other judges to speak. So I'd like the feedback from the judges on the quality of the projects, the quality of the processes that we have adopted, and any other general comments that you may have. Brijesh, please go first, and then Nilakant, and then no.
Sure.
You need to turn on your video.
So firstly, I should congratulate the CSI InApp team that has been coordinating this fantastically done, right? You've taken care of things to do with timing, communication, everything well. And then as judges, right, it was, we really didn't feel any inconvenience, right? Just everything was timed well, right? And then we go into a room, and then we have a discussion, and the panel was also, I think almost always we had a clear idea of what the marks should be, right? And all of it. It was fantastic. And I think in terms of the standard of the projects, I've been in panels for a while now, for many years, and I think all of the panel members have been and we're seeing this quality changing every year. It's getting better and better and better, right? And the newer generation is getting smarter for sure, right? And yeah, and I think from autonomous cars to identifying birds, all sorts of things that have very commercial dimension, things that have very deep social impact, that whole diverse ideas, diverse concepts, all of it enabled with some fantastic technology. I think this is amazing. And I think CSI InApp is doing a great job as well in encouraging this. Thanks for inviting me. Thanks for making me a part of this event. Thank you.
Thank you so much, sir. It was our pleasure.
Nilakant, would you like to go next?
Yeah, okay. So, all CSI and InApp both are very intimate to me, being for the past 28 years or 28 or 30 years being associated with CSI, and being associated with the CSI is also associated with Satish and Raja also. So it's a really happy thing to be part of this event. Regarding the, coming to the projects presented here, I don't know whether it's a lack of time for the participants or something. No, many things just I felt as not so complete. I think that for this kind of project, that is 6 months of period total at the beginning. Yeah.
Yes.
So I don't know what makes it to have a more complete project to be presented here. Most of them are okay. There are certain projects which are mostly complete, but many are part of incomplete sort of thing. So that's the only comment about the projects. But for that, the organizing of this event of final evaluation was also great. And congratulations for all the team members of InApp and CSI who made this work. Thank you.
Thank you, sir. Thank you so much.
Yeah, go ahead, Vishnu.
Yes, this is one of the prestigious event of Computer Society of India Trivandrum chapter, and it is happening in the 9th time. It's a remarkable one. The next year, it is the 10th time we are going to conduct this particular national level student project. And fortunately, I got chance to evaluate all the projects right from the beginning, including this time, so that I'm getting the depth and the progress of thinking level of students. It is, remarkable that, or it must be presented that over the years, the quality is improving. As Nilakandan sir said this time, in somewhere some lacking is there for completeness, but it's a negligible one. Anyway, the quality is improving, and I wish this will be one of the prestigious competition in nearby future, and it can be identified from its name itself. Okay, thank you for InApp for coordinating all these activities. It's a tedious task, I know. It is conducted and organized very smoothly. I take this opportunity to thank the entire InApp team, including Sadish sir, Vijay, and Amarnath Raja sir. And especially the Biju sir also contributed a lot over this competition. Thank you.
Thank you, sir. Thank you so much. Sir, you're on mute. Sadish sir, you're on mute.
So thanks, and once again, I'd like to thank the judges for sparing their time and their wisdom, which has actually made a material difference to the, I'm sure it's made a difference to the teams also. And we will be in touch with you regarding the next steps. We have not finished scoring the last project, so we now have to go to the room and score that project also, and then decide on the ranking of the projects. So I'd also like to congratulate the team who has managed this whole event very smoothly, including the compeer, who's been very good at her job. And we were wondering what will happen if everything became virtual. But now we think it is much more convenient and much more efficient and environment friendly to have it in a virtual mode. So that's it. I don't want to keep the judges too long. It's already 2 o'clock. So we will, can you put us in our room, please? We will finish the judging.
Yes, of course. Thank you so much for your valuable comments. You may move to the breakout room now.
Thank you.
I would like to take this opportunity to thank the 7 project team that presented today. I hope our judges were able to throw some light into your project and hopefully make it all the more perfect. Finally, I would like to extend our sincere gratitude to the audience who stayed on till the end to support the teams and also learning something new in the process. I hope we were able to kindle some new ideas into the minds of many. Before we wind up the event, I would like to say a bit about the webinar series planned. We feel it would be very useful for a large number of enthusiastic students to gain insights from a rich interaction with accomplished people from the industry as well as academia. Therefore, it would be our pleasure to announce a 3-day webinar series starting from July 2nd to July 4th. Topics like entrepreneurial, data science, biomedical engineering, and bionics will be discussed by eminent speakers. We are also planning to host a panel discussion on the topic, Reimagining the Future of Education, with eminent panelists who are pioneers in their domain. The results of the final round will also be declared as a finale to the webinar series on July 4th at 6 p.m. More details regarding the webinar series is available on our website as well as our Facebook page. Once again, thank you for being a part of this event and making it a grand success. Thank you and have a good day. This is Akhila signing off.